you won't see in the world market because the oil companies, of course, don't want this on the market. It's just a wooden frame. It's got a auto switch on it right here, an automobile switch, which...
I'm going to get closer.
Okay, turns it off and on. I put a cover over it, a jar, to protect it. Now, it's compressed. The material in this is made of, one rod is made of 73 different elements. The other side is made of 74 elements. There's one additional element, and that's why one is negative and one is positive. The one builds up electrons. The neutrinos that strike the Earth 24 hours a day and other things striking the Earth, the combination of them causes electrons to build up in one of these rods, and it depletes them in the other side. Much like a solar panel works, very much like a solar panel. But a solar panel needs light 24 hours a day if you're going to use it 24 hours. Otherwise, it only works when the sun comes out. Now, this here, as you can see, very, very light. Very light. Has practically no weight to it. But there's plenty of energy there. Now, as I run this up the rod, you can see.
Let me get a little closer there. Okay.
These are Christmas tree lights. 110 volt Christmas tree
Let me get a good close-up of those lights. Let's see those lights again.
Okay.
All they are is what?
Just regular Christmas tree lights.
Yeah, but hold out your hand so I could see it a little bit better. The light bulbs. I want to see the light bulbs.
Okay.
Without them being lit.
Oh, without them being lit.
Yeah.
Okay.
Just hold them there for a second. And all they are is grouped together and a little tape holding the ends out,
Yeah,
right?
they're just grouped together here. There's 3 of them together.
Okay, so now what you're doing
For
is
the
just...
purposes of something bright so people can see.
So you're putting one wire on one rod and one on the other, is that correct?
One on the other.
Okay.
Just like negative and positive.
Now
Just
turn
like
the rod sideways so we could see them individually.
Okay.
There we go.
Now, it's not a battery because you cannot light these with a battery. Now,
Okay.
and to show it's not a battery, anywhere you move it up and down the rod, the lights work. See? See, anywhere. Down here. Oh, yeah. The same. Anywhere you want to put them, they work. Now, there's no power buildup here. Now, to show, let's take something a little bit bigger. This is a 25 watt bulb. It's 110, 25 watts. Now, let's see what happens when we put that on. Now, of course, it won't be as bright because this takes a lot of amperage, you know, and the wattage. This here, the watts on this thing here is only about, right now, about 18 watts only, and this is 25 watts.
Now, do the rods get hot?
No, the rods don't get hot. The light bulb is hot.
Yeah, because it's...
Yeah, it gets hot. Of course, you can't see the heat there, but now I'll give you a good shot of the light here.
Okay. Yeah, got it.
Now you need a very big battery to do that. If you want to do that with a battery, you know, that's to show there's no power here as far as storage power. It stores a certain amount of electrons because it builds up. Now, let's cover them. We're going to cover them up. So now no light can get to them. So that we can show they're not like a solar panel. Now let's turn the switch on. So the power is now going from the bottom terminals through the switch here to the top here.
Right, okay.
Now we use these 2 terminals on here because sometimes at the cave site we used to use this to charge the big battery. You see? So that's why we put those terminals on there. Now let's black it out. See if we can still light it. See what I mean? You don't need light. So we're not getting it from the fluorescent lights here. We're not getting the power from the fluorescent lights.
Right.
Controller that's going to cause the power to come in from the wall into this whole situation, the electricity. All right, when he turns the power on, it's going to light this light bulb at a certain intensity. See, it's not all that real bright, but he's lighting the light bulb up with whatever power we need right now. Now what he's going to do, over here there's an amp meter. You notice right on the power controller there's a voltmeter, and on the amp meter we're getting what? 0.62. That's the amount of amps that we're getting. Drawing 0.62 amps. Now over here is the wave generator.
Magnetic wave generator.
Magnetic wave generator. And the magnetic wave generator is not really on now. And what he's going to do is, when he pushes a little switch over here, then the magnetic wave generator is getting excited. When the magnetic wave generator gets excited, you'll notice the light bulb will burn really bright. This is a 100-watt light bulb. It'll burn really, really bright. Now, what's happening is we're set up so that all the back EMF from this magnetic wave generator, like when you have a cycle, you get a spike. That spike is back EMF. Funny thing is, like you said, they've been trying to get rid of that spike for a long time. Pretty hilarious, isn't it? Anyway, so that spike back there, you get that spike every cycle. And so what he's doing is he's capturing all the energy from the spike as all of the atoms in this iron collapse. The electrons collapse in it as you're taking off the energy on and off. That's what a cycle is. As you're taking off the energy, it's collapsing, and all that back EMF is being captured in two capacitors, right?
That's correct.
And right in the capacitor, then he's able to take the energy from the capacitors, free energy in the collapsing of the spike, and put that into the light bulb. That means that if he could put that into the light bulb, you wouldn't need as much energy coming from the wall to still burn the light bulb, because you're capturing the energy from the magnetic field. Okay, now what Carlos is going to do to show to us that he's really able to do this, he's going to flip a switch over here, and then this is going to start charging the magnetic wave
coils,
generator,
the coils, the internal coils.
You might explain some of that, what the internal coils. So you got a coil, and then the electricity comes in. How does it take energy from the magnet?
Okay, well, we start to pulse the internal coils in the magnetic wave generator, and we have the split coil set up here pulsing the magnetic field in both directions so we don't magnetize the iron. We have also a secondary set of coils on the outside of the circumference of this unit to take advantage of the magnetic field being produced across the poles where the most strongest fields are going to be made. This also is going to give us kickbacks and extra power, but we're not using that right now. We're going to demonstrate the kickbacks just on the electrons in the iron atoms coming back and storing them into the capacitor to power the bulb. So
Okay, good.
when we turn it on, we're going to start to pulse the internal coils.
Okay, see, now we just turned it on. The light bulb got really bright. Our voltage didn't increase, but obviously our amperage did. Our amps went up to about 4.5, 4.4, 4.4, not about 4.5, I would say average. 4.5 amps. So now we're charging this, and we're getting back EMF, right?
Yeah, we're getting back EMF.
Now, we're getting back EMF now, but it's like we get one cycle, you know, a little bit of back EMF. The way we increase that back EMF, how do we do that,
Is
Carlos?
to bring up the cycles.
We had to make the cycles happen faster. So Carlos is going to do that now. He's going to bring the cycles together, and you're going to notice, as he does, the amperage is going to go from about 4.5 down, because it's going to take less power there, because these capacitors are going to be making up the power into that bulb. Carlos, go ahead and increase the frequency, and let's see what happens. Notice the amperage is coming down, it's dropping, the bulb is still staying bright. The voltage is not changing at all on the power source. So the amperage is dropping, bulb is still bright. Amperage is dropping, we're down to 2.7 from 4.5 to 2.7 amps already. Bulb is still burning bright. Wonder if we can cut that in half. What's half of 4.5? 2.25. We might be able to make it before the brightness changes. Notice the brightness, we're 2.46, 2.3, still got the brightness, 2.26, 2.25. Cut that power in half. And nothing but back EMF. That's the energy coming from the electrons in the iron, right?
That's correct.
So the electrons in the iron itself, which are replenishing their energy from nature, are supplying the excess power to keep the bulb lit on 2 amps instead of 4.5 amps.
Right, because the coils are consuming the energy right now, and the idea is to get it to a point to where we do less work on the coils and get more kickbacks, and this
Yeah.
is the direction that we're heading.
There you go.
You know, and there's a lot of different things that we could do to produce the same effect besides using electricity.
Right, but we're not going to tell them about
we're
Mark.
we're not going to.
All right, now, what we're going to do though is we're going to go over here, Mike, the cameraman, is going to take a picture of the scope there. And on the scope, we're going to let Carlos explain to us, show us graphically what's happening with this spike action here.
Okay, these are the waves of the 2 different coils, and you know, they're on and off time. This is the duration of the energized coil. And what we're going to do is we're going to show you now the spikes that we're capturing, that we're storing in the capacitor. There's the spikes coming up. Okay, you can see it's a really high, probably 600 volts coming back. And so now the idea is to squeeze as many of these kickbacks into a 1-second time frame to give us this more back EMF and collect more energy out of the electrons in the iron.
For free.
For free. So here we'll bring up the frequency now. Still getting a good kickback, and we're collecting them now. We're starting to collect more and more,
Well, the amperage is dropping like crazy.
and until you reach the iron's core limit. And here we can squeeze more back EMFs,
Bulb is still burning bright.
and there we can.
Now all that is free. All those spikes there
Yes,
are free.
all that, it doesn't cost you
It's
anything.
all coming from God in the electrons making the exchange in the material of the iron.
Returning back to where God made it.
Yep.
Okay, we are disassociating the electrons, lining them up, and then as we turn the power off, they're collapsing and they're generating these spikes, which is also energy, and that's what the capacitors are collecting. And now the idea is to collect as many of them as we can in a given time frame to produce the.
So if you're putting the power in, all you're doing is using man's power to excite the materials to extract God's
Exactly.
power from the materials themselves. So you're using man-made energy to then get free energy from the material themselves.
Yes.
So that's less man-made energy you need, the more free energy you get for the same job.
And that's.
Which I will demonstrate in the demonstration. So we will get started here just shortly. We first wanted you to kind of look at just the machine, and we have a tachometer, we have an amp probe that is an RMS, and we also have a fluke meter that is an RMS fluke meter as well. And we're going to show you how fast the machine is running and how many amps it's drawing, and of course the return voltage after 1 hour's running. Alright, we're now taking the reading on the batteries, and you can see from the multimeter what the readings are. And this is we'll call this battery number 1. Okay, and we're going to look at battery number 2. This is the next one. Battery number 2. Okay, and now we're going to look at, we're going to start the process of the system up, and we will take a measurement on this in a little bit of time here. And we'll focus in on the scope. We're going to be looking at the scope here just shortly. Okay. I'm going to start the process of the system up right now, and we will get on with that. To the opposite side over here. We're going to wait till this gets up to full speed. When it attains full speed here, then we're going to be looking We're going to be putting some return voltage on here. Return voltage is on now. We're going to walk over to the scope. We're going to look at the scope. See if Walt can zoom in on this a little bit. We're going to get up to, right now we're at a 100 volts. 100 volts at 0, so we're looking at a little over 110 volts, peak to peak, almost 200 volts negative. I'm going to stretch it out a little bit at 10 milliseconds, and we're going to look on the scope here at something very interesting. I'm going to switch this from, right now on the menu, we're going to see this is in the DC scale mode right now, a DC sine wave. I'm going to switch it over to an AC sine wave. You're going to see that it doesn't change, not one iota. There's the AC sine wave. I'm going to peek it back up over into the DC mode. And you can see that this waveform here has not changed. I'm going to step over to the, this is a TAC, Pioneer, model 36. We're going to take a measurement, and I don't know if you can zoom in on that or not. We're going to take a measurement right there on it. And I'm going to let you see that, if I can get it adjusted just right, on the PhotoTAC eye here. The reading is 5,000 RPMs. We're going at 5,000 RPMs. I'll put the amp probe on over here, and I'll let him zoom in on the amp probe so you can see what the amp load is. And right now at 200 amps.
Can you turn it? It's got a glare.
I'm gonna calibrate, make sure it's at 0. Let's see if you can see it there. It's at 0.0.
Hang on a second.
And then I'm gonna put it over here. And then I'll have to angle it to see if we can get the shot. Let's see if you can pick it up. Can you see that? It's at
there you go.
10.6, 10.7, 10.10, 10.7, 10.8, and it fluctuates between 10 and 9. The system is just kind of setting and running now, and it's really running nicely. We have return voltage that is going back into the batteries. We will be coming back in about approximately 1 hour to check the battery voltage. So we're going to let the machine stay on. The machine will be running now for 1 hour. 30 minutes into the run, and we just want to show you that there's only one line cord over here going from the scope. There's only one line cord that's feeding over to the scope, and there's not anything else. There's not anything else here. Just this one line cord that comes over to the scope so we can make our readings. And we want to show you that so you'll know that there's not any hidden wires or anything under the table or anything like that. Now we want to go over here, look at the wheels back over, back here toward this area. And Walt's going to move he's going to move the camera so we can get a shot off the side here so you can see all four of the coils here on the unit. Okay, now we're looking at the end shot where you can see most of the coils themselves. And you're also probably seeing this little orange battery over here. By the way, this battery will no longer be in the picture because we can take the battery voltage that we're using here to power the eye and come right off of the 12-volt battery here. And otherwise, we don't have to have another little battery here. We can just eliminate that. And when we get the box that's coming in, we're going to have a control panel on there, and this battery will not be in the picture. Yet the machine will still be able to do everything that you're seeing right now. Now, as you're looking back down at an angle right here, you can see these things turning. We are spinning at 5,000 RPMs. You have to take my word for it because we cannot hold the tack at set level whenever we make the measurement, and it is peaking at 5,000 RPMs. It's moving quite fast. We are
capable of driving this with very little bit of input power. And as you'll see at the end of the 30 minutes, in approximately about 30 minutes, we're going to take some more readings. You can see the waveform on the scope. You can get that in the picture. Can you get it from there, Walter, or you have to move the camera?
I might be able to get it from here.
All right.
I can barely get it.
The waveform hasn't changed any. And the interesting thing is, again, is that no matter if it's in DC or AC, the waveform is the same. And that's pretty interesting in the fact that it's able to power the bulb over here, and we're running at 5,000 RPMs, and we don't even have any work on this, on the wheel itself. We're not using anything to work the wheel, and we're consistently running at an approximated voltage. And what we're going to do, after about the next 32 minutes, we're going to go ahead and turn this off, and we'll make a measurement.
Alright, it's 9:45, and if you notice, it's still running. And we'll get over here, and you can tell the scope is still the same. Signal still hasn't changed any. I'll give you a real good close up. Still lighting, and we're going to probably run it for a few more minutes here, and then we're going to shut it off.
We've been running for 1 hour here, and you can see the scope is exactly the same as before. In fact, the voltage here is, and you can look at the scope here, it's 120 positive, 120 volts positive, and it's going to 165 volts negative. In 1 hour's run, this has not changed. You can see the bulb lit brightly over here. You can also see the output of the system feeding back over to the batteries. You can still look, and I'm going to go over here to the RPM tach, and we're going to monitor the speed again after 1 hour's run. And we are looking at a little over 5,000 RPMs. That's what we're looking at. Right there, 5,000 RPMs, a little over. And then we're sitting here looking at the amp probe. I've got the amp probe on here and monitoring the system back, and we're reading about 10.2. And see if I can get that in there. You can see it fluctuating a little bit. It's getting 9.9. Sometimes it reads 9.2. So with a 0.2 on the zero, if you look at the 0.2, it's got about it'll say 0.0. So we're pretty much back where we were. We actually are running exactly where we left off. And now we're going to go back and monitor the battery voltage, and then we're going to kill the system, and we're going to watch and see if the batteries themselves build back up to a certain voltage. So we'll go back and through. Right now we'll take a voltage reading, and we are reading right now, looking at the meter, we're reading 24, looks like 50, 24, 50, 25, 49, 29, 50. And I'm going to go ahead and start taking the system down so we can monitor the battery and see what the battery comes back up to. I'm going to go ahead and kill this. This is what I'll do. That takes that offline. And immediately, we're beginning to see the meter itself going up. We're at 24.87, 24.89, 24.90, and that's constantly going. We're going to make sure that stays on there. So after 1 hour's run, we're going to be looking at the voltage to the batteries, 24.95. And if you notice this immediately, as soon as I turned this off, and we went back and started monitoring the input to the batteries, is climbing. 24.98, 99. 25 volts right now. At 25 volts back on the batteries. And that is extremely interesting. We got 2501 and it's still climbing. 2502. And I guess what we need to do is just leave this on here and let this just keep on climbing. And I'm going to take it off for a minute so I can just hook it up so we can keep reading it. So right now we're at 2504 and climbing. We'll probably let this run or lapse off for a little bit of time so you can get a very good idea of what the voltage is doing in this process. If you notice the whole time the bulb was steady, it never did change, not one time. The system is continually here climbing back up again for the full voltage reading. And we're seeing on the Fluke DVM meter a 25.22 voltage. We started off at 25.66, so 25.22. We use 440 millivolts approximately. Actually, I think if we let this stay a little longer, it'll probably get up a little higher than that. So for an hour's runs we've used 440 millivolts. And I think that's pretty phenomenal. I hope you guys enjoyed that demo, and we'll be sending this off right away, and you have a good day, and get back to me, let me know what you think, and we'll talk to you later. God bless.
All right, you guys have a good one. Bye-bye.
There's a 21-to-1 gearing up for this speed, this flywheel right here. This is going 21 times faster than the unit. As you see, the pressure is still right about at the vapor pressure level, around 800 psi. The pump is the circulating pump right now is idle, waiting for liquid level to come up enough over a standpipe for it to pick up. If it doesn't pick up enough, one of our
the thrust we got. You see this little collar right over here on the shaft? Well, we had to go to that big old collar and make it steel hardened to 100,000 shear value because we first started out with this collar. You see that big piece of steel there? That was the collar, and look what it did to it whenever we turned it on and we started applying that power to it. And by the way, these are pins. Those pins are steel hardened pins. It takes about 60,000 pounds of shear. And look what it did to them. Just snapped them right in half. So we knew we had some power when we turned it on, and the first thing that happened on the shaft was it just twisted the shaft and just tore that stuff to pieces. So we've got it real well fortified now. If all of us pulled against this wheel, we took about 30 people, we couldn't make this wheel turn. So when this comes down, though, it'll start turning, and you'll see the momentum that it builds up. Now, over here, we got the receiver, just like the receiver on the Joy. So once the CO2 comes out of the engine, liquid, it comes in and fills this up with liquid. You got a low side, and you got a high side. And you maintain that low and high side all the time. So it'll just sit here and run and run and run. So I guess with that explanation out of the way, I might as well just go ahead and let him turn it on. Rick, my assistant, why don't you just go ahead and turn it on. Now what he's going to do is he's going to go to the back and he's going to take the wheel off top dead center. When he gets the wheel off top dead center, the wheel will start turning. Now Charlie, you can just show us right here that the pistons, we got a double piston. One of these pistons go down while the other piston is coming up. So you see that one is rising while this one's going down. You hear this thing going? There's a lot of power there. Now when it hits the top, then it will get another hit, boom, and it'll go back down the other side. Now if you want, Ron, what we can do is we can just take a shot right down the middle here and you can get those wheels. Now imagine a ton of weight spinning that fast with that kind of momentum. That's a lot of power. This wheel, you notice, is going very slow, about 10 RPM. That one in the back is taking off. Now, if you want to, Charlie, what you could do is just go back there and just get a closer look at the power on those flywheels. See the power on those flywheels? Now, let me tell you something. There's a lot of power being expressed right here. A lot of power. You hear the noise whenever those things are resonating. They sound like church bells. Okay, Ron, now, if you just take a look at the top here, right up on the top, we've got the high pressure that's the pressure of the temperature of the CO2 in the building. And then the low pressure over here, that's the differential. So the difference between the high pressure and the low pressure is what's causing this thing to run. And it'll just sit here. Now, it doesn't go very fast, so let me tell you something about this. It's good that it doesn't go very fast because this would require no maintenance at all. This thing will last 100 years. That's how. This electricity right here, now you see it's upside down, but that's where it's at right there on the screen. Okay, 7. So we got 7 amps, 110. Okay, Ricky, why don't you make sure you pump over there, right? Ricky's going to turn the pump on. We'll start pumping the CO2. Put it on there. Okay, can you see that one?
Yeah.
Got it?
8.9.
8.9. Okay, good enough, Rick. There it is. Roll it now. Making electricity. You will go up and down.
This is the Tesla turbine. This was developed by my hero, a man who I think is the greatest scientist that ever lived. We built it from his writings and designs. We talked to other researchers with the Tesla turbine in the process of building it, and they did have a lot to offer us, but we also discovered that there are a few unique things that evidently they're not thinking about. We did build it, and boy, I can tell you one thing. There's a tremendous amount of power in this device. It's unbelievable. This little bitty guy just took off, and as a matter of fact, it started going so fast and had so much power that at one point in time we just couldn't control it, and it came unloose from its moorings, and it almost did kill 2 of our researchers. But it's got a lot of power, I can tell you that for sure.
Generator of a special design. It's referred to as a transforming generator because it combines 2 separate technologies. Inherent in this structure are both a normal alternator and the makings of a transformer. And the reason why these 2 technologies are combined in this way is because this device is capable of doing something that a normal generating apparatus cannot do. Effectively, these windings can talk to each other. They communicate by a magnetic flux exchange. And in doing so, they change what is referred to in the electrical vernacular as the source impedance of the generator. Now, the reason for doing this is kind of interesting. Everybody's talking about how important it is to upgrade all of our technologies and save energy and what have you, and yet some of the most basic apparatuses that we use have never been revamped in the best way to achieve these ends. This particular device is intelligent in the sense that it monitors the amount of power that's required by the load without the aid of an electronic regulator, and in doing so it ensures the delivery of a constant power to the load at hand. Now, to demonstrate this and to demonstrate the fact that this generator is capable of tracking what we call dynamic impedance loads, what we're going to do is basically provide you with two different demos. The first one, we're going to energize a standard high-intensity floodlight, and you can note the voltage on the screen here if you can see it. And I'm going to bring it up to its normal brilliance at 120 volts, which will be generated within the generator. Then we're going to shut it down, and I'm going to replace this bulb with a mercury vapor lamp. Now, a mercury vapor lamp is customarily powered through a device known as a ballast. And the ballast tracks the changing impedance of the lamp and prevents the lamp from exploding by absorbing too much power. This generator, by virtue of its unique windings, can do the same thing and thereby eliminate the cost of a ballast. Just picture the effect of having an entire parking lot lit with mercury vapor lamps and having no ballast. For your information, the cost of a ballast is at least 50% of the entire fixture. So that'll give you an idea where we're going. Without further ado, let me get on with the demonstration.
Okay, so here we go. We're going to turn it on and light this one first. The interesting thing is this one doesn't run with any ballast, so we're proving here that we don't have any ballast. You're also going to see a sine wave that's pretty typical for this particular bulb, a sawtooth wave.
Yeah, the voltage on this generator will change as a function of the impedance. You can see the waveform here is pretty clear. Eric is turning up the intensity on the scope. It's primarily an altered sine wave that looks a lot like a sawtooth function. Anyway, the bulb is lit to its full brilliance. We have 120 volts RMS, and we're pulling a nominal amount of current. Just a second. Let me shut this down. Now, if we get this other lamp in here, what I'll do is I'll set the voltage to the same voltage as we had before, 120 volts, turn the machine on, and you can watch the intensity build. And if all goes well, this will start to assume the properties of a square wave, which is the machine's response to the dynamic impedance of the lamp.
By the way, you can't run this one without ballast. The other one you run with, and you prove that there is no ballast. And so this one right now, if it lights, that alone is a miracle. Oh, a miracle.
Now you notice that the waveform is bouncing around a little bit. That's because the plasma in the bulb is gaining strength. But eventually, when everything stabilizes, it will form a wave which is approximating a square wave. The reason that this is interesting is because a square wave has a higher order of harmonics in it than a normal sine wave, and therefore it represents a greater amount of energy being delivered to the lamp.
Go. So now what we're doing, he's taking his fingers. If you notice, it couldn't possibly be liquid nitrogen at 300 degrees below zero, or his fingers would be frozen. But he's levitating that, but you notice that it also wants to go to the left or the right because we have magnetic parts on both ends. A close-up also reveals to you that that is definitely not a spinning magnet. It's dead quiet, but his fingers are also showing you that it's not it's anything other than room temperature. So there you are, levitation at room temperature in a Meissner field.
Okay, basically this is a Yokogawa power analyzer. It's got a computer in it which is trying to figure out what it's doing right now. Okay, it's all done going through the auto diagnostics. The top display here is going to show you the line voltage that we're using. The middle display is trying to say power factor, and the bottom one has been set up to display watts. Now what we're going to do is really quite simple. There's two bulbs here, and there's a selector switch, and there's a variac. Variac takes power from the line, supplies it to this switch, and on one selection I can route the power directly to this first lamp, and on the other selection the power has to go through this oscillator circuit before it reaches the lamp. Now the meter is hooked up to the supply side of this, so it's going to see both effects, and it's going to register faithfully what's occurring. Now, let's first check it out by doing the positive power part of the demonstration, which is essentially the way your home works, the way most things work in the world right now. I'll bring this up, and as you can see, the bulb gets brighter. And I'm not going to go all the way up with the wattage because with the voltage, because this experimental circuit has low voltage transistors in it. I don't want to wreck anything, but I want the comparison to be fair. So we're doing about 96 volts here. Our power factor is about unity, 0.999 or 1 when it makes up its mind. And the wattage that we're looking at right now is 69.2 watts. And these are 100-watt bulbs, but without having the voltage up to 120, you're going to get a little less out of it. So that's all you got. It's a standard bulb. It's getting hot. It's getting luminous. All the things you'd expect. Now, we're going to turn this back down. Remember that number. It's 96 volts. I'm going to turn that down. I'm going to select the routing of power through the oscillator, and we're going to do the same thing again. So let me bring this back up. If you listen, you can hear the thing chirping away over here. There's about 96 point something. Okay, so we got the same voltage, 96, but look at this power factor, negative 0.032, and look at the wattage, negative 15.7. Now, that's a little bit peculiar.
Going back the other way.
You got it. That's the whole point. We're sending power back to the power company, and that's the significance of the negative number. Now, the interesting thing about it is, see, power is like anything else. It can flow. It doesn't care which way it's going. All this hoopla about draining it only one way is so that they can also drain something out of your hip pocket.
What I'm going to do is I'm going to dial up some voltage here. Now I'll show you that there really is electricity here, because you'll see the effect on the light bulb. See that? That's what Nikola Tesla is known for. The man that could have changed your whole entire world, and you never would have paid for electricity in your lifetime, who could have given you free electricity 100 years ago, is known for this right here, little games that you sell in little novelty stores. That's pretty sad, folks. That is pretty sad. Now, right here I have a single wire, It's wired in right here. How many people know you can't send electricity over a single wire? You can't do it. Now the fact of the matter is, what we're going to do is we're going to use this wire as the ground. Why? Because they'd get mad at me if I drove a spike all the way through the floor of the foundation and tried to hit the ground out there on both of these sides of the stage. So since I can't stick these in the ground, I can't ground them. The only way I can ground them is with a single wire. So electricity is going to go through the air, and it's going to come back here, and what's going to happen is, by the way, if I just took this light and I would have touched anything that was grounded, the light bulb would light. Now, we're going to send the electricity all the way over here to this receiver. Over this cord. Move my thing over here just a little bit closer, Ricky. Let Ricky do it. Okay. I can fire Ricky. You I can just get mad at. No, I'll never fire you, Ricky.
Slaves have to be sold.
Slaves have to be sold. Than me. Probably everybody out there is a whole lot smarter than me, but I'm lovable anyway. Besides that, I own the company. You got to put up with me. Teddy bear. All right, now let's try it again. So you notice that it doesn't work if it's not grounded. So I've proven that point, right? Now we got it grounded. Look at that. Electricity's going from here over there. Now you notice that I'm standing here. I'm in terror. My hair is going up like crazy. Live electricity is coming across this stage. You see me interfering with it. That candle is flickering like crazy as I get over here. But you'll notice that if I get over here and I do it, it is flickering like crazy because it's regular electricity there where I'm interrupting those electromagnetic fields. But over here I'm not doing anything. I can dance or do what I want to do. I can dance like David danced. So you see, live electricity can indeed be shot through the air. It can happen absolutely harmlessly, doing no negative impact on the environment or on individuals whatsoever. And all we would have to have is little towers that are sending it through the air as far as anybody wants to send it. And it would be more efficient than any grid system or any wire that we got out there.
All of that is because now what we're going to do is I'm going to take this ordinary light bulb and I'm going to prove to you that Tesla was right. So I'll just go ahead and prove it to you. Now this is a fluorescent bulb. How many people know you can't light a fluorescent bulb without ballast? Got to have ballast. Well, this one doesn't have any ballast. And also, this is a 12-volt battery, and you can't light a fluorescent bulb on a 12-volt battery, and especially without ballast. But I'm going to set this up over here so that my associate can do exactly that. And how many people know that in order to send electricity, you need to have a positive and a negative? You've got to hook a positive to a negative. Well, we're going to show you that this is hooked up kind of unique because you're going to see you don't have to have a positive to a negative. And I'm going to just let my associate explain that to you.
Okay, we have a 12-volt battery here and a little box. Now this little box is not ballast, but it has an input side and an output side. Positive, negative on the input, positive, negative on the output. Now the input, we disconnect across the terminals of the battery. Negative, negative, positive, positive. On the light, we're going to take one of these terminals from one side of the light and hook it up to the positive here. The other terminal we're going to take back to the positive side of the battery. Hook up the power, lights the light. Now this is pretty strange because normally you'd have sparks flying and sorted out battery and all kinds of strange things going on. But just to show you that I haven't reversed the terminals inside of the box here, I'm going to switch this one here over to the negative side, and it doesn't light the light. So I haven't made any switches inside the box. Now, something even more amazing, if you take one of these off.
Now, you notice that when it takes one wire off, now we know we have to pass electricity through two wires, but evidently when you pass electricity through one wire, you only get half of it.
See, because you notice that the bulb's only half lit here. So you only get half of it through one. No, you guys aren't buying that, are you? Okay? Well, you see, you can't pass electricity through a single wire, so what in the world is going on here? Well, what's actually going on is I'm completing the circuit right now, because you notice wherever I hold this, that's where the light goes. So it goes wherever I put my hands, and it's only going to be as lit as I allow it to be, because when it hits my hand, the circuit is completed through my body. That's because right now what is happening is, he's got a wire going up to his hand, you see that? And now the power is passing through his body, and then his body is sending the power through the air to my body, and my body is completing the circuit. Obviously, I really am completing the circuit here. Now, this is kind of interesting because right now what is happening is he's a Tesla coil, I'm a Tesla coil. Wouldn't you like to be a Tesla coil too? So power is passing right through the air. Now, we're going to show you something. We're going to show you that we are indeed doing this from the air, because the next thing I'm going to do is I'm going to put this speaker down, this microphone down, and then we're going to clasp hands. We're going to grab hands together. We'll show you the power of unity, solidarity, and brotherhood as we grab hands. We'll also show you we're completing the circuit directly, and watch what happens. Okay, so we are indeed completing the circuit. All right, now I want to do something else. What I'm going to do next is I'm going to take an ordinary bulb, just like that bulb, except this one is burnt out. You notice that? This is burnt out. This is a burnt out bulb. You can't light this bulb anymore. So not only is it pretty terrible, pretty amazing that you can light one of these without any ballast and with a 12-volt battery, but I'm going to go all the way over here across the room so somebody doesn't say, well, yeah, we're standing on top of one another for crying out loud, we're in an electrical field. I'm going to send electricity all the way over here to the whole other side of the stage, and I'm going to use a bulb that's burned out to do this. So we're going to take a burnout bulb. Now I'm going to take a single wire. So you notice here I've got a single wire going all the way back to him. The reason why I have one wire, you can't pass electricity over one wire, but I'm not grounded and he's not grounded, so we need a ground. So we have to have one wire to complete the circuit for the ground. By the way, Nikola Tesla did this 100 years ago when we were riding horses and buggies. Nikola Tesla 100 years ago sent electricity that he took from the ionosphere. He sent it across the countryside 26 miles away, where he had one of his little Tesla coils stuck in the ground. There were no wires at all because it was already grounded, because that was in the ground, the other one was in the ground. He's not grounded, I'm not grounded, so we're going to need this. But 26 miles he passed electricity. Guess how efficient it was? 100 years ago, it was 99.9% efficient. Hello. Now, right now today, I challenge any electric utilities executive, any engineer who works for the electric companies, if you can take electricity past 2,000 kilowatts of electricity, 26 miles, over any wire that you want, 99.9% efficient here, 100 years later, be as efficient as Tesla was 100 years ago, I'll give you $10,000 in cash. But my money's safe, because you can't do it. Now, so he actually was more efficient 100 years ago than they are today, passing power not through wires, through the air. Now let's see if we can complete this circuit here. You notice we're doing the same thing with a burnout bulb. So here we have a burnout bulb. We're lighting it again. He's passing the power from me. He's holding that in his hand. You notice that I'm completing the circuit again, just like before. Wherever I touch it, that's where it's going to end. Now, watch. I'll prove to you that he's sending the power to me for sure. It's going back over a single wire, but it's coming between his body and mine. He's going to take his thumb. Now, his thumb's on the end of the wire, so as he lifts it, he breaks the circuit. So watch what happens when he puts his thumb up and down. See the bulb? He's breaking the circuit. He's sending the power to me. Now, he go ahead and stop. Now, I can order to start again. How it happens. Stop. Now, also while by the way, this is the way God makes halos. He uses all of our burnout fluorescent bulbs. Get on to your car and modify your car and run on this water. You can run on this water right now. Same car you're driving right now, no problem. Just make a little change to your carburetor, that'd be about it. Okay, and then what he's going to do then is, now as the gas comes in, we're mixing air with it, and that's what makes it explosive. This is a little 5 horsepower Briggs & Stratton, single piston, but it works exactly the same way any internal combustion engines work. Okay, running that on nothing but water, that's going to get the car engine in your car. Okay, that's good enough. Now, in order to modify your car, all I need to do is put some little cells in there on the cavities of your car to be able to make that water gas. And as we make the water gas, then what would happen is we would have a little battery to be able to use the electricity to electrolyze the water. And then you just run down the road with a battery, some cells in your car, and ordinary car with a tank full of water, you're off and running.
Here, this is a 4-cylinder engine. We are going to run this 4-cylinder engine. We're going to run this 4-cylinder engine on Brown's gas. So we're going to show you not an engine cycle, we're going to show you an actual engine running on Brown's gas. Now, how do you make Brown's gas? You use water. And so this engine is running on water. That's the power source for the engine. Water. So we're going to be putting this gaseous state of water into the engine, and we're going to be powering a 4-cylinder engine, and over here will be condensing, and we'll be getting water out of here as an exhaust. So the exhaust will be water. It won't be a whole lot of water, just a little bit of water, but there will be water because we're just going to run it for you for a short period of time. We all ready to do that, Eric? Okay, looking good. Let's do it. Okay, we are now going to do that. It's okay, Russ. We're now going to do that. Ready? Okay, now you got to hit it with the spark. Make sure you hit it with the spark, buddy. Okay, crank it first. Okay. Okay, give it a little more gas. You see it running? Okay, ladies and gentlemen, there is an engine running on nothing but water. This is a Brown's gas engine. It's running on water. We're kind of condensing here. Water. Foot-pounds on 1 cylinder, then multiply it by 3, and that means that you would be getting 300 foot-pounds of torque on all 8 cylinders. So now, whatever you get on 1 cylinder, multiply it by 3, and that's what you would get if all 8 cylinders were modified to the Fisher-Brauer concept. Now, this torque wrench right here, the red line starts right at 0. If we put it on and it goes across here, 85 foot-pounds is right about here. So if it goes about an inch, about halfway across, that's 85 foot-pounds of torque. Now, if it's 260 foot-pounds on all 8 cylinders with the internal engine process, then if we divide that by 3, we should be able to get 85 foot-pounds out of 1 cylinder. So if we put this on and we get that needle to go about halfway across the white, then we are getting the same power out of the Chrysler internal combustion engine
without spark plugs in the Fisher-Brauer concept. Now, just for the fun of it, we will look at the biggest engine that Chrysler made. This is the biggest V8 engine that Chrysler made. This is 380 foot-pounds of torque. Now, if we divide 380 foot-pounds of torque, we get about 123 or 125 foot-pounds. So, if we put this torque wrench on here and we excite the cylinder and it goes all the way to 125 foot-pounds, which would be right about there, just about a half an inch or so from the end of this white. If it went all the way there, then ladies and gentlemen, modifying this to a new engine process that does not run with any combustion, with any spark plugs at all, no internal combustion, modifying the same internal combustion engine that was made by Chrysler, then we would be making the smallest engine they make have as much power as the biggest V8 engine they made. Now, that would be pretty interesting and pretty incredible. So what I'm going to do is I'm going to turn this over to Eric Brauer. I'm going to let Eric explain to you how he's setting this test up himself.
Okay, what I will do is top dead center on one of the two cylinders. Pretty much either one will work, but I use the one that's got a good advantageous spot for top dead center. That's pretty good. Okay, then I get it up to where it's near the handle that stops it. Give it some room here. And bring it off top dead center a little bit so that I'm somewhere between the two 45-degree angles of top and bottom dead center to find out what it's going to kind of get in an average of torque. Okay?
Okay, now this is all set up. Now before you do it, Eric, get ready. Now I want to remind you that if this goes off over to about here, it gets the same power that it had when Chrysler built the engine, even though there are no spark plugs and there's no combustion going on here at all. If it goes within about a half an inch of the end, it is getting the same power of the biggest V8 engine Chrysler made. And this is the smallest V8 engine Chrysler made. All right, we ready? Let's go ahead and crank it up. Let's see what it does. I can't help it. I gotta laugh every time we do this. We destroy a torque wrench every single time we test this because, as you will notice, we've come a little bit further along than the biggest engine, V8 engine that Chrysler makes. Because if it went right about to here, it was as good as the biggest engine Chrysler makes. However, that's where it went. By the way, Sears Roebuck guarantees this for life, and so you might say this demonstration was sponsored by Sears Roebuck Corporation. Okay. The engine the way it's going to be made to modify to your car, because what happened was we found out that we had some seals over here, and the seals were popping whenever we put it in, so we had to change the valving structure on it, and we didn't have time to change it. So we are going to run this engine for you. Eric is also going to show you that you can accelerate and decelerate the engine with this little unit right over here, just like you would with the foot feet in your car. And so Eric is now going to turn this one on and run this one for you and show you the acceleration and the deceleration. And so he will run that for you now. This one isn't going to make noise. Okay, you see the engine? See, he's slowing it down. Okay, so that's the engine right there. He can slow it down, speed it up. We can't go real fast with it because we'll break the seals. So we have to solve the seal problem before we can completely change it. But you notice the engine right there? That's a 4-cylinder engine right there. Running, there's no noise, without the exhaust, and he can accelerate and decelerate it. Okay, so ladies and gentlemen, the low temperature phase change engine is right here, right around the corner. Now,
is called a GravTap, gravitic torque amplifier. And in essence, it's a device which is capable of extracting useful work from a gravitational potential. Now, most of you are all familiar with gearboxes, and you know that normally what happens is that power is always conserved in a gearing arrangement because of the fact that the circumferential ratios transmit the velocity component to the power, and the radii of the circles involved transmit the torque. And so they are effectively locked into unity by the constant pi. In this particular device, what we're basically doing is creating a gravitational potential by virtue of a disequilibrium, which is created by the swash plate at the bottom, and that causes a perpetual inclined plane into which the weight continuously rolls. And in doing this, it creates a levering action which provides an output torque which can be used for doing useful work. There are some proprietary aspects to this, so I won't get into it in great detail, but what I will do is start the unit for you, and you'll notice when you look upon it that there are some very unusual oscillatory motions involved. Some of these concepts, as Dennis mentioned, were extracted from work done by Tesla, but instead of using mechanical approach, Tesla had done similar things with the Earth's electromagnetic field and the Earth's electrostatic field. So without further ado, let me just start the unit momentarily.
Okay, we're going to start up the electric motor. We're going to start this thing turning. Now obviously we're driving that around here with this electric motor, which is using energy. But you're going to see that we're tapping into the gravitational forces of the Earth and we're magnifying the torque. Okay.
At the top here is a Prony brake, which can be adjusted to provide varying amounts of output torque. For this demonstration, we didn't load it down very much, but it's right now producing about 40 inch ounce times 24 inches, which I don't happen to have a calculator on me, but that's a considerable amount of torque. If we had the proper metering here, we could also demonstrate to you that the input torque is significantly less. Past tests have demonstrated that this device is capable in its present geometry of producing a ratio of approximately 2 to 1. In the future, we hope to bring that number very far up, and that's going to be difficult because of the fact that the geometry involved here is making use of mathematical concepts which are extremely nonlinear. So we have every confidence we'll solve the equations.
You can see it with your own eyes. I have seen a camera. It's a laser camera. You can have that now and then, just don't put it in yet. This laser camera, you can dial it in like a set of binoculars, and you can look right through a 3-foot solid concrete wall. If I had a 3-foot wall between me and you right now, I could be filming you, we could have a television monitor there, and you could be making faces at me through that wall and be looking at yourself on the monitor. I would see you just exactly like you are in full color, and everything that you wonderful, beautiful people are would be right there on that film. Now, I could also do that through 6 inches of solid, high-carbon steel, stainless steel. I could also dial it in and look through this gentleman's clothes right into his body and watch his heartbeat on a videotape. And we could see his heart beating right on a video. We can look in and we can see all of his internal organs. We can look in and we can see his skeletal system. Go ahead and play that tape. I'm going to show you a human heart beating through the clothes, a close-up of a foot, not X-ray, laser, no radiation at all.
You can just go right into the human body, look at a tumor or anything else, and not even have to do any x-ray or CAT scan or anything. No negative impact on the person whatsoever. Okay, show the film.
I will now go over to the other room so you can see me walking there, forth and back.
Yeah, muy good.
See the X-ray and the laser ray on the foot belonging to shell. Latest development in technology in the optical medical laser camera. Here we can see the heart pulsating. This is truly revolutionizing within medical research.
Highly explosive shell. They are both about 40 centimeters below the surface. Here you can see the control system for our laser camera. We are now out in the dark in order to demonstrate our product. Here you see our first generation model, which we have done a considerable amount of modifications on in order to prepare this film for your convention. This camera we here can see is suited solely for mine search and cannot be misused to any other purpose. We are sorry to tell you that we can't use the camera seen here to medical purposes, i.e. use as X-rays, because the laser strength is too intense. As BVT will be granted exclusive rights for USA, Canada and Australia for the medical model, we also have considered to grant the same rights for the mine camera for the same countries. Before we can do this, however, we must conclude our relationship with some earlier cooperation partners. And a highly explosive shell to the left. Both are about 40 centimeters below the surface. When the commercial mine camera is ready to be sold on the international market, this will have a very good solution and give very clear pictures. What we have here, however, is the first generation laboratory model, which we have modified to give you a demonstration of this product. We will reveal to you a little about how our camera works. The camera is based on two types of laser. One laser has a constant frequency, which are polarized with the other laser, which gives pulsating radiation. This laser is also calibrated to function on another frequency. What we do is to shoot asunder the atoms in the laser, and this causes the molecules to move sidewards. Thereby the laser penetrates the matter it is directed towards, for instance a wall. In addition, we have a simulated gamma beam lying very close up to gamma radiation, which contributes in making the pictures clear. It has gradually become a well-known technology that when you shoot asunder the atoms in the laser beam and cause the molecules to move sidewards, you can run the laser beam through matter, which normally never can be done. Unfortunately, we cannot reveal any more about our technology.
Bicycle here, and we got a very unique tire on the front end. I don't want to be that far out. Okay. Very unique tire here. Now, this tire could be a car tire, a truck tire, an airplane tire, a bicycle tire, motorcycle tire, any tire whatsoever. Do we have our little unit? Okay. I want a volunteer from the audience to take this fake pick here that we have. See, you just push in and it goes into the handle. Oh, it doesn't work. Oh well, take it anyway. Take the pick. Anybody wants to do it? Come on up here. Now we're going to take this regular bicycle tire. You're going to stick the pick all the way through the tire. Stick it all the way through the tire. Just go right from the edge all the way through. Just push it through. Push it on through. Leave it in when it's there. Okay, now you see this? The pick has penetrated the tire. Did you hear it go shh? You know why it didn't? There's no inner tube in this tire. You never put air in this tire. This tire never needs air. No, you got to pull it back out now. Okay, pull it back out. Anybody want a jab? Somebody else wants to take a run at it, that's fine. Take another shot at a different place. Take another shot. Okay, try to just put that right through there and destroy that tire. See that? Now, pull it back out again. Doesn't it feel like a regular bicycle tire? It's the same. It's nice and soft. And so we can now make that tire on your car where you can have these tires on your car. You buy 4 tires. That's it. You don't need a spare. You never put a spare in the back. You will never, ever go flat. You can go 60 miles an hour up over the curb. You don't get one flat tire. Go down the Baja, no flat tire. We have shot into this with a Mauser 16 times with a Mauser into a car tire, and it did not go flat. Just continued to go. By the way, as you're going down the road, the air is being replaced because the tire breathes. So the tire never gets over a certain temperature. It never gets hot. Lasts a long time. You can also recap it and just keep going with it. So now, when you have your car, you put the tires on. When the car dies, you take the tires off and put them on the new car. Back to the old West days where you put the saddle back on your horse. Okay, Charlie, go ahead and ride it out of here. You'll notice that he's doing something you couldn't do with any other bicycle tire after that demo. Now he's painting up this piece of metal. He's taking a little battery. He's hooking up the electrodes in this battery, low voltage, putting a little butter on there, and he's cooking himself an egg.
Low voltage. It uses 35% less energy than conventional heat generating systems. 800 degrees Celsius can be achieved with only 100 volts. The company says that it's identified more than 200 applications. The paint can either be brushed on or sprayed on to almost any surface you could think of, and even to a few that you might not think of. Like this sample material to be used as lining to warm up the fashion conscious. Battery-powered lining in clothes may soon be on the catwalks and in the shops, but it's the industrial applications of the paint which will have the most impact. Because of its viscosity, shape is no barrier, and that opens a range of possibilities. It could mean a new method for de-icing aeroplane wings, tarmacs, railways and roads. But direct application isn't always viable, and MRX offers alternatives. Imagine this is your tiled bathroom floor with water-filled, heat-conducting pipes underneath. Now, normally the water is heated by conventional means, but with this new system, we have a boiler here that's insulated and also coated with the MRX paint. The boiler is connected by wire to a low voltage system, which heats the paint, which heats the water. Power consumption for underfloor and radiating heaters can be as high as 280 watts per square metre. But with MRX applied under the floors, to the walls and ceiling linings, Rustall claims that consumption per square metre could be reduced to just 76 watts. That would make the cost up to 75% cheaper. And unlike traditional radiators, which concentrate heat in only one area, the paint spreads the heat evenly over the treated surfaces. And it's not only under and in the house, it's soon to be applied to the top of the house as well, to be put on roofs to melt snow. In fact, paint panels like these will not only be producing heat from electricity, they'll be generating their own energy by harnessing the rays of the sun.
Gas inside of it. We've sealed all the openings, and the opening that we are going to use to light this with, we have a kerosene soaked piece of twine. Ricky's going to put the 5 gallons in there and then put the cap back on. Then he's going to light the twine and get out of the way, and we're going to see what happens if the explosive-proof mesh prevents this gas tank from exploding, or if it doesn't. So that's what we will find out as soon as Ricky gets done filling it up. The kerosene, I don't know, let me see if I can get it a little closer. You can see the twine by his feet there with the kerosene that's soaked in it. We have our gentleman standing by with the fire extinguishers just in case the explosive-proof mesh doesn't work as advertised. Ricky's just about done pouring in the just about finished pouring in the gasoline. When he does, he will put the cap back on. He will tighten it down so that it's a good, tight, solid fit. And then he'll light the fuse. See the top of the container? Putting in this tank at 70 parts per million.
Now this is 70 parts per million.
And see what happens.
This is out at our voluntary sanctuary for volunteers.
Okay, he has the fuse in. He's pulling it out away, grabbing the torch, lighting it, and there she goes. Fire is approaching the tank rather rapidly. We may not blow up the tank, we may burn the property down. Okay, there goes the fire up to the tank. In the hole of the tank, remember there's 5 gallons of gas in this thing. Burning. Well, no explosion so far. Looks like the fire's burning itself out. 5 gallons of gas in that thing. We'll keep the camera on this thing till there's absolutely no fire left, and we will, looks like it's working so far. Looks like it's burning around the hole. If there's fumes coming out of it, it may continue to burn where the wick went in, because that's the way this stuff works. You can poke holes in this can and light them on fire, and they'll burn up to the hole where the liquid's coming out, but they won't continue to burn.
To power this engine right here. How would we power this engine? Well, ladies and gentlemen, if you don't have gasoline, you got to have something powering the engine. You got to get energy from somewhere. Now, by the way, the prototype that we're working on, the idea that we have that we might be able to do, we're close to it, might be that we just power it from the energy we take right out of the air directly. Now, that's pretty interesting and pretty exciting. However, if we don't get that done, we're going to need power. And so what I've got in my hand right here is the world's most efficient thermal storage device. This is the most efficient heat cell in the world today. There are 4 little cells here. This is a 4-pack. You can get a 6-pack too if you want one. Now, this right here will store heat energy more efficiently than anything else on the planet. Each one of these little cells, we had the world's record when we used sand in here. And with sand in here, we could store enough heat energy that we could hold a lot of energy, but we found a substance that's 9 times the specific heat of sand. The substance that we found would have the capability of putting 60,000 BTUs of heat energy in one of these little cells. So the 4 of these together would have almost 250,000 BTUs of heat energy. Now this engine over here is going to be a whole lot more efficient than the one you got in your car. The one you have in your car right now runs at less than 20% efficient. This engine right here would run at almost 60% efficient. So between the additional efficiencies of the engine and this thermal storage device, we could store enough heat energy right here to run that engine for about the equivalent of 1 full tank of gasoline. So we store the heat energy in here, we got a tank of gasoline. How many of these could we put in your engine compartment on both sides? How many of these could we put where the gas tank used to be, because we're going to take that away from you when you come to our facility to get your car modified. And so, ladies and gentlemen, we can store all the heat energy you need for a month's worth of driving, and all you have to do is just plug it in once a month. Now, you see how we put the energy in here? That's an electric cowl rod. So this is an electric cowl rod. We can plug in with that cowl rod, put the heat energy directly into that unit, and all we have to do is just plug that into electricity one time in a month, and then for a whole month you can go drive around, and you have to remember to plug it in again once more at the end of the month.
When Morris applies his invention to another surface and then applies heat to that surface, well, watch what happens.
And you can see
a plastic that refuses to burn. A discovery that any Nobel Prize winning scientist would envy. At approximately 2200 degrees Fahrenheit, the plastic glows red, even bubbles a bit, but it refuses to ignite.
I'll move the torch away.
Okay.
Like so.
You can barely feel it. Whoa.
But just watch this. If I turn the flame off and remember that it was producing 1200 degrees Celsius, if I then crack it open, what's more, the egg hasn't even begun to start cooking.
Turn the cylinder, get the linear motion, the sprags will do the rotation, this will start turning. That right there is the compressor that will also be driving, and then this is the pump that'll be pumping the water,
And then that right down there will just be a bonus. We'll be also lighting some light bulbs we hadn't planned on lighting. Okay? Are we pumping water or what? Light the light bulbs. Plug in the light bulbs. What's wrong? You can't get them plugged in?
Yeah, we got a couple dead bulbs.
You got a couple of dead bulbs? Oh, well. Is that still pumping water or am I crazy? All right. So there it is. This is turning that, which is pumping the water. Michael.
Broken plug. What can I do?
You got a broken plug. Okay, well, I guess we can't do much about the plug. Sorry about the light display. Last time we were at it, was all, it lit up all of them and just kept lighting them, and this thing just keeps pumping water. But see, it doesn't make an awful lot of noise, does it? Now, if we have a driver and we're driving a pump to pump this water, what else could we drive? Obviously, if we're driving a pump, couldn't we be driving a generator? Couldn't we be driving a lot of things? So let me tell you what this is doing. That's directly driving the compressor. You hear the noise there? Goot, 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 goot. That's trying to compress some Freon. Please give me some Freon to compress. And so that's trying to compress the Freon. So this would drive the compressor that ran the boiler, that ran this little air motor, that run the pulley that gives us direct drive. Now, we could just hook up to the pump itself. We don't have to have a pump. So a farmer's already got his own pump. So all you do is a direct drive hookup with a pump. Do we need the sprag clutches? Do you hear them squeaking, going back and forth and squeaking? It's because this guy didn't oil it. But would it make a lot of noise? It makes some noise squeaking. Well, now what we're doing is we are going to use this direct drive compressor, that same cylinder, but we're not going to have any of this. We're going to have a hydraulic process instead with a hydraulic motor that makes no noise at all. Here is water in a cylinder. We are going to show you the implosion engine cycle where you could run a car engine on water. We're going to prove that to you with Brown's gas. Now, right up here, my associate is going to release the water into the bottom cylinder. And so he's just going to release the water from the top into the bottom cylinder. We're going to fill the bottom cylinder up with water. And then once the cylinder is completely full of water, we're then going to take Brown's gas back through this machine, this welding machine. We're going to push the Brown's gas after we purge the line back in, and it is going to displace the water and put the water back up in the cylinder again. The little ball will go back up where it was. Then obviously this tank will be completely full of Brown's gas. When it's completely full of Brown's gas, we are then going to take a spark plug over here. We are going to hit this Brown's gas with a spark. When we hit the gas with a spark, it is not going to explode, it's going to implode. And when it implodes, it is going to turn from 1,860 particles of gas to 1 particle of water. Remember, the relationship is 1 to 1860. So then it will turn into 1 particle of water. There'll be a couple of drops of water in the canister. Then what else is there going to be in there besides water? Well, that means there's 1,859 particles of nothing, and that, by the way, is about the best definition of a vacuum I can give you. So it is going to be a vacuum inside this cylinder. So once we hit it with a spark, we will create a vacuum inside. Now the way you'll know there is a vacuum inside is we've got a vacuum gauge right here. This vacuum gauge, once we hit this with the spark, we get the vacuum, you're going to hear a little ping, a noise like a firecracker, and that's going to be not anything exploding, that's going to be the sides of the canister trying to cave in because there's a vacuum on the other side. If there was a vacuum in a tin can, it'd just suck it quiet, just suck it together. However, the atmosphere is not enough pressure to collapse the canister, and so the 14 pounds per square inch of pressure that's in this room will try to collapse the cylinder, but it won't be able to. That's the noise that you hear. Then we're going to prove that we got a vacuum by opening a little stopcock here. The vacuum gauge is going to go to the right-hand side, so you're going to see it go from the left, no vacuum, over to the right with a full vacuum in there. Then when we prove we've got a vacuum inside, this right here, you know what you just did? That was open. All right, we're going to load it again because the gate right here was open. And so all the gas you just put in there just kind of went right back out the gate. Okay, turn the unit back on. We'll load it up again, just take us a minute. This guy's from California, so you got to forgive him, okay? I mean, California is part of the United States also. He is still an American. You know I love you, brother. All right, now, so we're going to release this down. Now, once we get this completely released down, we'll load it back up again. This vacuum meter is going to show you that there is a vacuum, and then we're going to leave that closed so that we don't escape all the gas out to the air. And then what's going to happen is, once we get the implosion, create the vacuum, I'm then going to let him open this up, and when he opens this up, the air in this room right here, 14.7 psi, the air in this room is going to start rushing into this little ball valve, and on this side we got a piston, and it's going to try to drive the piston up because the air has to fill the vacuum. That's the law. God says air will fill the vacuum. And so as it rushes in to fill the vacuum, we've got, now over here we've handicapped this piston somewhat. We've got 5 50-pound weights down here. As the air we're sitting in rushes in, it's going to pick these 5 50-pound weights, 250 pounds, up off of this platform, 1 foot in the air. So we're going to lift that all the way up, 1 foot in the air, and we're going to do that from the air pressure in the room right here. So feel your face right now. The pressure pushing against your face is going to now lift 250 pounds a foot in the air. Isn't that 250 foot-pounds? Yes, it is. And so we're going to show you 250 foot-pounds using 14.7 psi at sea level air pressure. So if you can imagine the air that you're sitting in, lifting 250 pounds a foot in the air, that, ladies and gentlemen, is incredible. Now, we've got the gas back inside again. Now we're cooking again. All right, let's try that again. Instant replay. Now, what I'm going to let my assistant do here now is he is going to hit that with a spark. So when the gas is hit with a spark, you'll hear a little ping, and that is going to be the sound. Go ahead. Yeah. You hear the ping? That is going to be the sound of that canister trying to collapse. Now he's going to open this up and prove to you there's a vacuum. Did you see that gauge go all the way to this side from that side? That means there's a vacuum inside this canister here. Now, with the vacuum inside the canister, my associate now is going to do the sublime experiment. He is going to lift this 250-pound weight a foot in the air using nothing but the air pressure we're sitting in. You ready to do it, California? All right, let's go for it. All right, there we go. You see that, ladies and gentlemen? 250 foot-pounds of power using the air that we are sitting in because a marvelous man named Professor Yul Brown cared enough to continue to pursue a dream and pursue a technology. And believe it or not, this shows that you got an engine cycle. How would we return it? We would use the gravity to do it. Go ahead and return it. Okay, we all set up now? Oh, by the way, you remember this implosion cycle? What if I then had this not sucking energy from the air, but what if I had it with hoses out here into a tank of water, and I was just sucking water right out of the tank, putting it into the cylinder here, and then sending it on. Ladies and gentlemen, with this process right here, we can pump water for farmers or for anyone else, even right out of the ocean, absolutely with no mechanical device at all. You don't have to have a piston. You don't need to have anything. All you need is a cylinder full of Brown's gas, hit it with an implosion, and then let the water suck in and through it. Let me show you that on videotape now. Next video.
That gas is going to then replace all the water within that blue container and the hoses. The purpose for moving all the water out is so that it can be a completely perfect mixture of the Brown's gas within the container to indicate the implosion. So go ahead. Okay, so you're opening up the first. So you've cleared out the first hose. And now he's going to continue to clear out the rest of the hoses. We're going to detonate, point to the unit. We're going to detonate a spark plug, which is going to cause the gas to implode. And please note the area down here where the water is located. I'm going to go down there swiftly so we can see how it works. We're going to detonate it now. You can see how the detonation took place and drew the water up, sucked up into the container. We're going to open up the valve again. By the process, just a moment, by the process of the gas being made by DC energy within these cells, it creates a 60 psi pressure. So what we're going to do is use the gas, which is created in one of the Brown's gas machines, to push the water up 1 atmosphere, which is approximately 10 meters now. So go ahead. That's going to go up and it's going to squirt out. Yes. Go over there. Okay. It's going to go up here, across inside, come down over there. Go ahead, open her up. Okay. So this shows the pressure of the gas which is being created, pushing all the water out of the container, up that hose. All right, very good.
Plug it in, turn it on. Now this one here has got 20 light bulbs on it, so it's a little different. It's not set up to pump water. This one here just
the house that can be built from the components described in our previous conversation. You can see that it looks just like any other house. I choose to call it the time bomb house. Time bomb because it can be built very quickly. A couple of guys working together can build this house comfortably in a week, ready for occupation. Using the components already illustrated, simple bolt-together connections, this house can be ready for occupancy quite comfortably at the rate of a linear foot a minute. Hello, Gail. How are you?
Good, thank you.
Bill Dodds has a dream too. He thinks he's found a way of giving people homes that are cheap, structurally sound and energy efficient. His secret? Plastic. There's not one bit of steel or timber needed to build this house. The whole thing can be made of plastic. This particular house is finished with plasterboard and timber as a concession to conventional building tastes, but the shell, walls, floor and roof, everything else is plastic. But not just any kind of plastic. Bill and his son Simon have their own secret formula. Bill won't tell us what's in it, but according to his successful building accreditation applications, Bill's houses are more durable and less toxic in the event of a house fire than timber houses, and resistant to earthquakes, cyclones and termites. In fact, Bill's houses exceed all Australian building standards. It's a house that fits like Lego with the other pieces. Plastics are energy efficient. The plastic house uses less energy than conventional houses at every stage of production. And because of the air trapped in its walls, the plastic house requires less energy for winter heating. The plastic house is 10 times more energy efficient than the average Australian home. This small 2.5 kilowatt heater heats the entire house. That's an 85 to 90% saving in electricity use every year. Since Bill Dodds perfected the technique of making houses out of plastic. Today, he's more certain than ever that it's the way to house the world. But it hasn't happened. His story is a perfect illustration of the difficulties you face when you try to change the way people think and when you're up against powerful vested interests.
Sideways. Okay, I want to try to get a sideways shot of it here if I can. Okay. Okay, now you see this unit right here? This is a big tire. It could be a truck tire. They just had a smaller tire for getting indoors. But imagine this as a big truck tire. Right over here, we got a hydraulic motor, electric motor that is going to power a hydraulic drive. And by the way, the pressure on this hydraulic drive is 70 pounds per square inch. Now this is a big hydraulic, this is a big truck tire, and over here is a hydraulic motor. So built right into the hub of this truck tire is a hydraulic motor. So we can put the hydraulic motor right into the hub of the truck tire. This hydraulic motor here, by the way, will give you 500 horsepower of torque. So it runs at 500 horsepower. You could put one on the two rear wheels of a truck and you could be tooling down the road with 500 horsepower here. Now, by the way, when I turn this unit on, I'm getting 70 pounds per square inch. I'm not going to take the time to get a volunteer because you know I wouldn't tell you if it wasn't true anyway. Got 70 pounds per square inch, and now all I have to do is just turn this thing and the truck tire starts running. Now, if the truck tire will roll at 70 pounds a square inch, what would it do at 2,000 pounds per square inch? 2,000 PSI would give me a lot more, but what about this? This one is designed to run at 5,000 PSI. Where would I get 5,000 PSI? If I take that panel right over there, I take a refrigerant, I put it in the panel, set it outside, the pressures will build up to 400 pounds per square inch. Right there, the gas, Freon gas or refrigerant gas in that panel, 400 PSI. I know that because we kept popping all the nipples on it. Now, by the way, 400 PSI, if I ran that into an intensifier and I could multiply it 15 to 1, what's 15 times 400? 15 times 400 is about 7,500 pounds per square inch. Now, this thing runs at 5,000 pounds per square inch. That would be more pressure than we would need to be able to drive this motor to turn this truck tire. By the way, if you were rolling down the road with this truck on here and you wanted to stop, let me show you the best brake you could ever find. Now, here it is right here. Just reverse the hydraulic fluid, but if you're going to apply that brake, you better have your seat belt on. Otherwise, you're going to be through the windshield. Now, let's shut this off and set it up the way you want me to. You all set to go? We're going to let Big Mike test the torque on this engine. Okay, now this is a torque wrench, just like the one we already used, and you know how big it goes. And so all we're going to do at 70 psi, we're going to see how much torque we got on that torque wrench there. You ready, Mike? Okay, you ready with the camera? All right, go ahead. It buried the needle, didn't it? And so lots of torque on that engine. This unit right here would drive a truck with 500 horsepower on both sides, and all I would need is refrigerant in those panels and a set of intensifiers. Where would I be able to put those panels on a truck? How about the side of the truck? I could put them on this side of the truck, I could put them on that side of the truck, and so as we're driving through the air, I've got them on the top of the truck and the sides of the truck. I could be taking the energy from the air to drive the truck from the energy I'm taking out of the air I'm passing through. And by the way, if you know anything about convection, you know that the faster we go, the more energy transfer we would get in a given period of time. The faster we go, the faster we could go. I could do exactly the same thing, by the way, with choo-choo trains. Slap the panels up on the backside, on the side of the cars, the box cars, and then take the energy from the air the box cars are traveling through and be able to apply all of that energy to the torque of the wheels of the box cars. A train that pulls a box car, by the way, uses 76 horsepower per box car, and this would give us plenty of energy. Actually, an engine a little bit bigger than this one right here, a motor a little bit bigger than this one right here, and the first demonstration would power a box car. So we can run the trains with no coal and no fossil fuels and no diesel or anything else. And we also could run the trucks with no diesel, no fossil fuels from energy we take out of the air, with a hydraulic process, with a low temperature phase change process, with a Brown's gas process. Are you beginning to get the picture here?
Well, here we are now standing in front of the Adiabatic bicoannular reactor. It's a little bit considerably bigger than the one you'd have in your home. This isn't the size you'd have inside of your home, but here's the feeder over here, and this is the size of a unit that would do a few million BTUs an hour for a motel. This is Bill Norberg here. Hi, Bill.
Hi, Dennis. How are you?
Okay, Bill Norberg works in our research and development department here in our facility, and he's feeding some green grass. You see this right here? Green grass, fresh cut today. Just like what you went out and mowed your lawn. So now you can get heat out of green grass. What else you got over there?
Well, we got some hickory smoke chips.
Okay,
hickory smoke chips.
Okay, hickory smoke chips. So you know what this is? This is the stuff that you make smoke with in your barbecue. See if we can make some smoke up here. Throw a couple of them things in there, and now I'll tell you what. What other kind of chips you got over there? Oh, chocolate chips. Okay, let's take some chocolate chips and throw them in there.
Cookies.
Okay. What the hell, just dump some of them things in there. Yeah. Now, what other kind of chips you got down there? Potato chips within a bag there?
Yeah, we have some potato chips there.
Okay, now how about potato chips? So it burns everything from wood chips to chocolate chips to potato chips.
We even have some other.
Okay, you got some other kind of chips there? What kind of chip is that?
Looks like cow chips to me.
Wood chips, potato chips, chocolate chips, and even buffalo chips. All right, buffalo chips. What else you got you can put down that thing there? How about some coal? Let's take some black coal over here. Now you see all the smoke billowing out of the top of this thing. I mean, the EPA would shut us down right away, right? Throw some black old coal in there. Show them the black coal here, the camera.
Here we go.
Okay, black coal. Throw it in there. Get a bunch of it there. Okay, get some, what else you got we can throw down there?
Some walnut shells.
Walnut shells. Okay, now we're going to throw some walnut shells in here. Handful of walnut shells.
Ground up walnut.
Ground up walnut shells. Okay, how about those egg shells? You got egg shells over there? So we got chips and we got shells. We can do chips. Okay, some eggs. Okay, the old garbage right down the old chute here. Hey, I saw this sandwich sitting up here. What do you think? Tuna fish sandwich. Mmm, delicious.
Put it in.
Stuck it in there. Make some electricity. This is the only way that you can use these things Chuck them in there.
Sunflower seeds.
Sunflower seeds. Throw some cigarettes in there. Hey, I'll throw a few more cigarettes in there. Got anything else we can burn here? Throw some more grass, green grass in there. Hey, what do you got over there? What's that thing over there? That box. Horse biscuits. Here, we got some horse biscuits. Okay? Horse manure. Well, by golly, I can tell you one thing. Well, this thing is hot. I mean, really hot. Now, let's get back over to the back end of this thing and let's find out what we got over here on this end. And we got a gentleman down here, a pyromaniac, a guy who knows all about pyro stuff. And a fire, he's into measuring temperatures, I mean hot temperatures. Let me introduce him to you. What's your name there?
I'm David Kramer.
David Kramer. And David, what are you down here to do?
I'm here to help you measure the internal temperature on the adiabatic bicoannular reactor using a optical parameter that measures the radiant energy in the infrared portion of the spectrum coming from the inside through the window to our unit. This unit is one of the best infrared units on the market. It's computer calibrated to NBS traceable standards.
Whatever he said, it impressed the heck out of me, and I tell you what, now this thing right over here, is this, what kind of thing is this?
Well, this is a digital readout that gives us the measured temperature in degrees Fahrenheit. Right now we're sitting at about 2770, as you can see.
2770. Now what is 2770? You talking about degrees Fahrenheit?
Yes, sir. Degrees Fahrenheit. I wouldn't trouble anyone with centigrade.
You mean to tell me that this thing is 2,770 degrees Fahrenheit?
Yes, sir.
From this are showing only about 400 watts. When I let it run for 20 seconds, it counted how much energy was in there. But 400 watts is not even 1 horsepower.
Remember, there's no grounds in this system. There's no electrons. I explained to you earlier. Instead of forcing atoms down to a solid material, system is set up so that it is already charged. It's just running down an empty tube. There's no restriction.
What's the energy that's coming through these wires? Is what you're saying that this requires 5 horsepower to run, which probably is the case.
Yeah, that's standard.
What's actually going into this is not what's running this. You know, I understand what you're saying, that this is generating more than what's coming out of the wall, but what's going into here, we're not getting 5 horsepower going into this, or 3 or whatever.
Or even 3, right, yeah, you're not going
This is rated at 3 and this won't even run 5 here.
That's why you're not getting heat. Everything okay, like I said.
That's why a little different than I even thought over the phone.
That's why I demonstrated the magnetic flux field. Okay. Let's charge for it. More here? That's right out of the other way. This really is. And then this top. Okay. Okay.
Come here, Brad, Billy.
Contact. Running. Running.
Running?
Yep, good.
18
That's good.
One shot.
to 16.
That's good. So that coil's getting hot.
Oh, that what it is.
Yeah, it's going to drop down to around 15 when the coil gets warm. Okay, well, I'm going to have to fire it up, so let's pump the water through there.
That's what they used
I
to
don't
do in the
think
train.
it'll roll
Contact.
Right, yeah. I don't know what, I don't know if we start on the skewer or not. I didn't turn the pump on, so.
Okay.
We're going to try with quarter.
It runs, man, it runs.
This engine does not burn oil. It has no metal-to-metal friction as in most combustion engines with surface bearings and piston rings, and it has a patented Ramjet combustion and steam turbine tornado power source that burns virtually pollution-free and actually oxygenates the air we breathe. The prototype has less than 35 parts with only 3 moving parts. Other technological breakthroughs in the engine are its fluid drive transmission with its variable pitch propeller weighing less than 20 pounds. This video presentation will give you an inside view of the inner workings of the engine. The Ramjet with the glow plug and fuel injection. This is where the tornado begins, with the explosion of the gases propelling them in a spiral direction to the intake port of the primary turbine as pictured here. The back plate of the Ramjet, with its spiraled surface, begins the swirling effect of the gases. The intake and exhaust port of the turbine housing is where the fuel mixture with the steam exits and goes to the secondary turbo, which goes to the turbine. Notice the half-moon shapes on the inside of the turbine housing. This is the rear hub of the engine and transmission with its output shaft that transfers the power to the differential. This is the inner turbine, the primary turbine. Notice the half-moon blades on the turbine. propeller. This is what transfers the power as the blades open to the output shaft. This is our hydraulic pump. Two aircraft engines. The ramjet is the area that the gases initially explode, forming the swirling formation into the turbine chamber. The gases enter the turbine chamber where they are picked up by the airfoil blades and are moved over to the exhaust port where they are then transferred to the primary turbo. The exhaust gases are then spun at a high speed from the turbo into the secondary turbine where this process is repeated. Simultaneously, on the opposite side of the engine, this same process has been repeated, at which time both of the turbos and both of the turbines are exhausting gases, which then go to our water separator, which takes the steam and turns it back into water, which is then recycled back into the engine. This is the point of entry of the water, which then turns to steam. The heat from the ramjets is what causes this steam, and this also is the propulsion where the tornado begins. Remember the airfoil blades with the half-moon shapes? The pressure goes to the point of least resistance. This is our ramjet tornado steam turbine engine.
Okay, no, I don't think you're quite there yet. You can use this if you want. How about that way? That okay? Big screen? Well, if you're on a big screen, all right, now. So he developed a thing called the fourth law of motion. Now, what if you were able to take that action and that equal and opposite reaction and take the reaction and apply that to the action? So the fourth law of motion says that you can not only get an action, but when you get a reaction, you can turn the reaction into the action in the same direction. So now you're getting energy from the action, and you're getting energy added to that from the reaction. That's kind of an interesting concept. Now to explain it, you got a device like a motor, an electric motor. Like you'll notice here, an electric motor. You notice here another one. Here another one. You got 4 of them there. 0 degrees, 90 degrees, 180 degrees, 270 degrees, you got a motor. Now you got a motor and it's got an armature and it's turning this way. It's causing a stator to turn this way. Now this isn't anything new. Got a motor, armature, and a stator. So you got the armature and the stator. Armature is going action, causing the stator to go this way. And over here, as this turns this way, it's causing this gear to go this way. So you got one gear going this way that's causing this gear to go this way. Do you see that? And so this gear is going the same way that this is going. So now the reaction is putting torque onto the same drive mechanism as the action. So now you're getting action, reaction into action, double action on that shaft. So that's the 4th law of motion. Now, over here, that's exactly what we would have here is we have a little rotor in the middle here, and the motors are on the rotor, and the motors are applying torque in one direction and it's spinning in the opposite direction. It's called counter rotation. So you got rotation and counter rotation. By the way, I can see a spiritual law in this too, something that Jesus Christ developed, something that nobody understood at first, and has been very hard to get people to understand, and that is when somebody comes and slaps you, that's the action, you don't react to them. Instead, you turn that around and you give them a positive action back. It kind of goes atypical the way we normally think. You hit me, I hit you back. That's action-reaction. That's the 3rd law of motion. But if you hit me, instead, I absorb that, overcome it, turn it around, and send something back to you that's kind of neat, then we got the 4th law of motion. Or 4th law of emotion, let's call it. All right, now, I'm going to show you over here a little device. Now, this device was developed by Carini in our research lab. He actually did this 30 years ago, right after he ran this car that I'm going to show you. Right after he ran this car and proved to the world 30 years ago he could run these cars on very, very, very little electrical energy and little car batteries. They blew up his research lab, they blew up his house, and they blew up a little shack in the back. They blew it all up just in case he had something anywhere. They thought they blew up all the cars, but the fact of the matter is he had given the car to a friend of his to use and put it in his parking garage. So they didn't really get the car. Now, it definitely delivered a message to Carini at that point in time that somebody didn't want him to do this stuff, so he tucked his tail between his legs and he quit. Carini actually had an accident about a few months ago, and he died. When he died, he came back to life. Then he died again. When he died, he came back to life. Then he died a 3rd time, and he came back to life a 3rd time. And then when he got off the bed, he said, boy, the Lord must have something he wants me to do. The guy's 80 years old. Then he got a phone call from me saying, hi, I heard all about your 4th law of motion, etc. I think we're ready for you. Would you like to come and work with us and develop this? And he said, gee, I guess I know what God was trying to tell me I ought to be doing. And so he did come down here and work with us. Now, this is his device right here. It was a little device that shows the demonstration. It's a little wheel here and a wheel here, and they turn each other. That's the gears. On the back side, I got a belt. But the problem we had was that in running this, we burned out the motor. So you can smell the motor all burned out. Basically, I was going to demonstrate this for the crowd today, but actually you can come back on Saturday at our research lab and watch me demonstrate it then. So I can't demonstrate it for you now, but I have a videotape that has that all on video, and I'm going to let them put that in the video camera now. And I will let you see the counter rotation test that we ran in our own research lab. Now, before you put that on, just put it in and stop. I'm going to show you the results. I don't care. I'm going to show you guys the results. Going to have to get over here, Mike, and hold that up if you would. I'm going to show you the results here, and then you can see it for yourself. So when you're watching it, you can confirm. I'll leave this up. You can confirm, yes, that's the number. Yes, that's the number. Yes, that's the number. Yes, that's the conclusion. Let me give you the conclusion, and that is we ran this motor two ways. One way without the belt on that made it counter rotation. So we just had a device that was going around with a motor on it. It was just like any other motor making a wheel go around. When we tested it, we had 219 RPMs at 13 volts, 15.5 amps, 200 watts. Now to look at this, the easiest way is just say 219 RPMs. When you see the test, just say, what was the RPMs? 219. And then you see what was the watts, and you say 200. Because it doesn't matter what the volts and amps are, as long as the watts are 200, it's the same basic thing. Now we ran it, and we were applying on that little motor there 6 inches of torque, so 6 inch-pounds of torque. Now in this test, that's what we had. Then we hooked it up to counter rotation. When we hooked it up to counter rotation, we were then getting, instead of 219 RPMs, 438 RPMs, twice as many RPMs. We had 14 volts going in, 12 amps going in, 168 watts of power. So we were using less power for twice the RPMs, and instead of getting the same torque, we got 7.5 inch-pounds of torque, more torque than we had on the other test. So, for those technical people, more torque with less watts and twice the RPM. What am I saying to you? More than 2 to 1. As a matter of fact, when we calculate this, it comes to 2.9 units of energy out for 1 unit of energy going in, and that's due to the fourth law of motion. Now we'll see what we left on the table in science. Now Mike, we'll just hold that up there, and we're going to go ahead and run this. You guys got it all set up there? I don't know if I rewound that or not, so if it looks weird, we'll just have to take a second to rewind it. Matter of fact, just shut it off at the beginning, because that one starts right at the very beginning. That's one of those weird things that I do that's weird that I actually start at the beginning instead of somewhere in the middle. If it's still rewinding, we'll just have to wait for a second. I've been doing a powerful lot of talking in the last 2 days. Have I not? You guys, you poor dealers, have had to listen to an awful lot of information, so you probably should do this to your ears, too. We back there yet? We got it rewound? All right, let's go.
And essentially what it is, it's a device which allows you to combine the action and reaction components of a torque system in such a manner that the resulting torques from both the action and the reaction are combined and applied to the same load. And there is a rather interesting increase in overall efficiency when you make use of this principle. Now the machine that you're going to see here is designed in such a way that the motor which is propelling it can be utilized in 2 different modes. One is when the rotor alone is turning the load, which is what you're going to see first, and the other is with the combined action as previously stated. So with that introduction out of the way, this is the machine itself, which is nothing more than a little frame supporting a specially designed motor, and has a jack shaft and some pulleys and 2 gears. The device you see in front of you here is a pony brake, a miniature little pony brake to measure the torque, and we will take the RPM readings separately with a handheld unit that records the speed. The input power is going to be monitored by a Yokogawa series power analyzer. which is about 0.25% accurate, and so we should be getting some pretty good numbers. So the first thing we're going to do is we've got the pony brake arm loaded, preloaded, to produce a torque on the system of 6 inch-pounds. And with that torque in place, we'll run the motor first in the normal mode configuration, and we'll record the numbers. And then we'll run it in the counter rotation mode, and we'll record the numbers. And then we'll draw some conclusions from the results. Ready?
Yeah.
Start at any time.
Go ahead. Okay. And what's your RPM?
219.2.
Okay, go ahead and stop it so you can set up for the next.
7.5.
Okay, he's got it set up for the counter rotation. You can see in the back that he has it set up so that
Shafts combined.
the shafts are combined to the one shaft. And we're going to run the test now with this. Right now, with the same setup, it's like 7.5 foot-pounds. Inch-pounds, excuse me, inch-pounds of torque. Okay, Jim's going to go ahead and start at any time, Jim.
All right, you ready?
Yep. Okay. Okay.
Our RPM reading is 437.7.
Okay, we're all.
And that means that we've enjoyed a ratio of improvement of 2.97 to 1 by simply rearranging the geometry of the drive system and making no other changes. So that's a significant effect, and the insinuation of utilizing this technology is that if you started out with a motor which was already designed for a higher efficiency, that you would probably get system efficiencies very close to or over Unity, at least if it behaves the same way as it's doing now. So that's our preliminary report.
Okay, thanks, Jim.
Sure.
You can just turn me back on now. Can you do it? Turn me back on now? All right, good. Okay, I'm back on again. I'm not very loud. You had to turn it down there. All right, so if you got it back up again there, all right. Now, this right here is the counter-rotation device. Now, what we did here is we have the rotor in the middle with the motors on it, and the motors, if you look here, you can see the motors are turning a belt. The belt is then applying torque to the center rotation here, and it's turning the rotor around. Now, the motors are supposed to be going this way while it rotates that way. What happened in the design of this is we had two cooks in the kitchen. We had Carini there, who was 80 years old, and we had a very ambitious engineer here that was working with him, who was trying to say that it wasn't rotating or counter-rotating, and he got Carini so doggone confused that actually this thing got built in a manner that it doesn't really counter-rotate. It's like as this goes around, the motors are going the same way that the whole thing is going around. So what we did was we decided that it was a bad idea to use the belts, and we went out and had this baby made right here. It's a gear. So it's a stationary internal gear. We made a stationary internal gear that we can put right in here and put it right up against this metal plate. So a stationary gear sets against the metal plate like that on the other side. And then through this stationary gear we have 4 pinions. The pinions are connected to motors, and the pinions would be going, the motor would be going the exact opposite. So the motor rotates this way as it rotates that way around it. Now that's counter-rotation. So actually what we did was we went out and we paid a lot of money and rushed the job and got all this made, knowing that we had this meeting here, and we went back to our machine shop to take this apart and put it all on here and run it counter-rotation for you today to prove to you we can do here exactly the same thing we did on the film there, which is pretty obvious. But our machine shop had a power failure. So in Butler we had a power failure and our machine shop went down. So without a machine shop, it was kind of hard 2 days before, or a day before this, to put it all together and get it to happen. So you have to have a little imagination with me. We're going to counter-rotate it. We're going to run it, but it won't be counter-rotated. So it isn't going to do the same thing that's on the film. And if you want to see it do it, you have to come back on Saturday, because Monday we go to our machine shop, we take the parts we got, we build them, we put them all together, move everything in, which is about a 1.5 day job, and you'll be able to come and see it. But you already got the concept, and you already know how the concept goes, and you see the over unity. So we're just going to run this now so you can get an idea of a unit that would be on your house. This is what would come to your house. It would sit here and spin around, and you're going to hear the noise that it makes in just a minute. Okay, we ready to run this? We're going to take, you see over here we got 3 car batteries, 12-volt batteries. We're going to start it on one 12-volt battery, and it's going to start whipping through the air. And then we'll engage a second 12-volt battery, and you'll see it goes quite a bit better. We also are going to put a load on it then with this little bitty generator here that can only produce about 1 kilowatt of electricity. That's all the size is. And it'll produce the electricity over here while it's running. But remember, this is not counter-rotation. This is rotation because we screwed up, okay? I mean, we made a mistake. Now, I didn't make the mistake. It was the guys in the machine shop that made the mistake. I want you to understand that. Right? Thank you very much. Because you know I don't make mistakes, right? All right, anyway. Hey, buddy, don't stand close to me. You're going to get zapped by a thunderbolt. All right, so anyway, we're going to run it for you anyway so you can get the idea. This is what would go on your house for a seed unit contract. This is all we bring, nothing else. We set it down outside of your house. It will take an electrician about 3 hours to install the whole thing, start to finish. And that's it. You could even put it inside anywhere that you want to have it, and then you're going to hear the noise that it makes as it runs. Go ahead. Okay, so then it just sit there and run. Now you hear all that noise? Sounds kind of horrendous, doesn't it? Let me get this microphone over here. That's going to just drive you crazy at your house. Okay, we got it going. Let's just kick in a second one. Go ahead, it's okay. You can take a shot of that, sure. Okay, now it's on the second mode. Now it's really whipping out. You'd never go at RPMs over this because anything over that you'd already be applying to the load on your generator, running all the lights and making the light. Okay, so there it is going. Now when you want to kick in the lights? You want to go to 3? Okay, he's going to kick in the third one now. Okay, it's kind of whipping out there, isn't it? Now that one's really, really going. But we would have, by the way, it'd be counter rotation, we would have loaded it before we ever got to that level. So that one right there is a kilowatt of electricity. You want to get another one? Okay, that's about all that one would do the way it is now, and it's not counter rotation. Yeah, you're tempted, aren't you? Nah, you're overloading it too much. Okay, so we are overrunning the generator. This would all be very stable, and it really wouldn't make noise as it's running out there and it's cooling your house. But I'll tell you, on those hot summer days, this is the place to stand, right here. Just don't have a tie on. Okay, tell you what, let it run there for a minute. I want this man for sure to get a copy, a film of that. All right, Jim, you got it? You got everything you need? Like me next to it like this.
There's 3 cycles of its rotation. Our 6-cylinder with opposing crank powers all 12 magnets each revolution. That means we have a 12-to-3 ratio above anything that a gasoline engine would perform. This standard golf cart is running approximately 12 miles an hour on our improved 1-horsepower flywheel motor. Most similar carts utilize a 3 to 5 horsepower motor in order to attain the same speed. The car is a geoprism equipped with our 5 horsepower flywheel motor. We have run this car on the street at 40 to 42 miles per hour using only 2 12-volt batteries, 24 volt, 9 amp, 2,160 watts. Actually, 138 watts less than a 3 horsepower motor.
Even if it's a small advantage, it's going to be something that's welcomed by all drag race drivers.
Well, we had a big head fire coming through the palmettos. It was really, 15-foot flames, some hot fire. We let it get up to the edge, and I went along behind it, and it was burned halfway through a palmetto patch. And normally with water, you can't stop it. Well, I hit it once. It was about 125 GPM on the nozzle. I hit it once. That was it. No rekindle. It was out. We kept going. It was really amazing.
Billing showed us 2 shacks side by side, one made out of geobond, the other standard materials.
Information only. Burn exercise is underway at this time.
With the Kansas City Fire Department standing by, both buildings were doused with fuel and set on fire. Within minutes, the shack made out of regular materials is on fire. The geobond house, not only is it not burning, you can actually put your hand on it.
Be careful, Barn.
Oh, it is right over here, over here. It's unbearably hot. And this
is perfectly cool.
Geobond may just be an idea whose time has come. Unlike conventional building materials, it won't burn. Unlike asbestos, it won't cause cancer. And if geobond does catch fire, commercially speaking, if it doesn't all
Okay, now this is able to throttle back in this wind and hold here, and showing 0 feet per minute up at about 30 miles an hour, sitting still. And by adding power, I can go up if I wish, right on up, and I can pull the stick back and actually track backwards, yes. And dump the nose forward if I want to come down, I power back, come down. And by pulling back on the stick slightly, holding here, coming up to full power, getting here to about 30 miles an hour.
controlled conditions. Toxic compounds are combined with reagents that promote detoxifying reactions. Now, over the last 12 years, Harry and Jean have concocted over 800 different recipes, and by recipes I mean mixtures of these solid wastes with liquid waste to make over 800 different end products. And they tell me that they expect to go on coming up with new recipes for many years to come. In a mixer, the pulverized solid waste is combined with the treated liquid waste mixture. After the solid and liquid wastes are mixed, polymer components are added. The wet pulp is then transferred to a form, extruder, or other shaping device. Pressure needed is mechanically applied. Uncontained, the polymers will expand in volume 25 times. Take a look at that reaction here.
Particular kind of products.
Okay, if you can look or feel, if you put your hand over it, you can see we have what we're after. We have the heat, we have the expansion, and the only thing left is something that gets hard fast.
Additional pressure is created by the expansion potential. Up to 50 tons of pressure can be achieved. The amount of pressure created varies with the desired density of the end product, which can range from 10 pounds to 100 pounds per cubic foot. Through chemical combinations, heat and pressure, a wide range of molecular rearrangements occur. All living organisms present in the waste, such as bacteria and fungi, are unable to survive in the high temperatures and pressures of the process. The end product is sterile, durable, non-toxic, and can be fire retardant and moisture-proof if desired. This is how the Hydromex process fabricates a limitless array of resellable building and construction materials, with no polluting emissions of any kind released and no unused byproducts.
A sort of high-tech coffee table.
Just look at the pump, that's all it is. Just a pump. You can hear the valve. You even pump here.
It's so simple.
That's it. That's the whole machine.
Where are you going now?
That's the whole machine.
That's it.
That's it.
Where's that go? Show me where that goes.
Right here. Can I lift that? Yeah.
Yeah.
There. That's it. There's nothing here. Just water and flotation.
And as that goes up and down?
Well, that goes up and down. That's where the wind does that for you.
Yeah.
The wind does that for you.
And it causes water pressure to build up inside?
Yeah. And you can go to any pressure. The big ones can operate probably right around 1,000 psi.
And then you send that water pressure ashore in a pipe, Satania?
Yeah, you send it to some kind of line.
Yeah.
And use it to make fresh water, for aquaculture, for generating electricity. It's like, I'll give you an example. Say you have a motor in your car, or wherever. I see the car, everybody knows car, right? And that motor will run forever. You never gas it up, you never grease it, you never put no oil in it, it don't make no noise, you don't make no fume. It don't cost you anything, but if that shaft is turning all the time, forever. You'll find a way to plug a generator on it, you'll find a way to use an osmosis system, make fresh water out of the ocean, you'll find a way to pump water for your aquaculture, or whatever energy you need. If you've got a machine shop, you want to turn some big equipment, that shaft don't cost you nothing. Another simple example is the faucet in your kitchen. You got, say, I don't know, 40 psi, most places 50 psi. If you could open that faucet and it'll run forever, you never pay for the water. You never pay for the pumping or nothing. All you have to do is put a little water motor on it and it'll furnish the heat, the light, your fresh water, furnish everything for nothing. That's what it is. But Mother Nature does it for you.
Look, I don't mean this question to sound rude, but if you're so smart, why aren't you rich?
That's a darn good question. I was rich. I had done it backward. Most people, they get smart and they want to get rich. I got rich first. Then being smart made me poor. So now I got to reverse that.
You said you had sex.
Now, this is the Weberg in the local storm with wind up to 80 kilometers an hour. As you can see, it's riding tremendous waves. These are huge waves. This would compare for 150 footer the equivalent to a tycoon of some kind. And there is no ill effect on the wave bird. Hard to get steady here. This is Mother Nature in all its fury.
In America. Few know, however, that bottled water is currently less regulated than municipal water. Legally accepted sources for bottled water may include wells, springs, and even tap water. In fact, the only thing you can be sure of when you purchase bottled water is that you're getting water in a bottle. If not serviced at proper intervals, home filtering systems, such as carbon and reverse osmosis systems, can become breeding grounds for bacteria and viruses. They can also be very costly and wasteful. For example, to generate 3 gallons of water each day, a reverse osmosis system can waste between 25 and 60 gallons a day. In nature, water is evaporated and drawn into the clouds, condensed as rain, and falls back to Earth. Instead of removing contaminants from the water, nature removes the water from the contaminant. The process filters the air, then collects the water, requiring no complicated plumbing. While producing drinking water from the air around us.
The best way to purify water is the way.
Okay, we're at Universal City Walk in Hollywood, and we're talking to people.
Back up away a little bit. Right there, beautiful. Okay, turn it around. Okay. Aluminum and the slag that came off the steel. Similar, but much more powerful than a thermite reaction. Apparently, you say that this is impossible with, the only way to do it is with this flame. With Brown's gas.
We have this reaction also with titanium.
You can have this reaction with titanium?
Titanium and what was the nickel or titanium?
Titanium and aluminum also.
But we also have nickel.
Oh yes, nickel also.
What about titanium?
Okay, now this is the torque amplifier. This is a very, very, very interesting device that operates on open-ended geometry. I'm sorry for the tape here. We lost the audio on this, so I'm going to have to narrate this for you. This is Jim Murray. He's demonstrating this with a flexible shaft. Now he's also dialing up right now, putting power into it, and so he has a meter that's measuring the amount of power that is turning a rotating flexible shaft. Now the flexible shaft, if you notice, is turning this device that is built at a 3-to-1 ratio. So it's a 3-to-1 ratio, and it's turning it. Now he's got a man from the crowd named Thomas, believe it or not. We called him Doubting Thomas. He was doubting everything we did, so we had Thomas come up and check all of the meters and all the devices. And Murray is now applying electricity with a meter that can measure exactly the amount of electricity going in. And we'll have Thomas come over now and take a look at it and confirm that we also have a metering device that is measuring the foot-pounds of torque. There's a lever that is 12 inches long. That 12-inch long lever will get a foot-pound. In other words, be 1 foot long, so 1 pound of force exerted on a foot-long lever is a foot-pound of force. And so they're measuring now the amount of foot-pounds of torque that are on it. I can't see any meters, and so I can't give you the exact number of foot-pounds of torque that we were getting, but now Jim is going back over to the device that is measuring the input of electricity and proving that, what the input of electricity is. It is also being confirmed by our Doubting Thomas that is indeed the amount of electricity that is going into that device. And so they're both concurring on that, and he's setting it and saying, yes, that's exactly the amount of electricity put in. Now, he has just, I believe, shut it off. And so we had test number 1, so many foot-pounds of torque at a particular RPM, and so that would measure the power or the horsepower, the mechanical energy, and we measured an exact amount of electricity. Now he has done this on the flexible shaft, which he is now removing. And by the way, as he's pointing out, this center shaft in the middle is a ratio of 3-to-1. That length that it's going around in circumference in open-ended geometry is 3 times the circumference that it normally would be just turning on the shaft. And so he's now removing the flexible shaft, and they can drive this directly on the shaft. So they've got a benchmark of something to compare this to, where they can compare an orange to an orange, because they have the RPMs constant, they have the amount of energy going in, and they have the foot-pounds of torque on the end. Now, Doubting Thomas is examining the shaft and looking for any hidden wires or anything in it. I'm talking to him there and making sure that he's satisfied with everything. Then we're going to hook this up to drive it directly. So we're now going to drive the motor directly off of the driver, and we bring the scale back over, and we set the scale down so that we can measure the amount of pounds of pressure that are being exerted on the scale. And since the lever is 1 foot long, 12 inches long, then we would be able to measure that in foot-pounds. And so we now have got a comparison. We're going to now turn it back on and see how much electricity it takes to get it back to the same amount of foot-pounds of torque. And so when we turn it on to apply the pressure to get the foot-pounds of torque, he's got Mr. Doubting Thomas coming to look and to make sure that we're doing everything right, and we've got the proper measurement on the torque meter. And there we do. We've got the same torque that we had before, but now we look at the amount of electricity that's doing it, and we have a major, dramatic drastic difference between the amount of electricity that is being used in this particular case to do it. It can't even get the amount of foot-pounds of torque that we had before. It's confirmed. I don't remember the numbers. I wish I did remember these numbers, but I can tell you as an eyewitness that the ratio, this torque amplifier always doubles the torque of the mechanical device. It always doubles the torque. So when you use the same amount of electricity, you get twice the amount of torque or foot-pounds of pressure with the same RPMs that you were pulling it before. And so it always doubles the torque. And so the amplification is always 2 to 1. Always.
Distance right in Augusta, and so it's very much easier to produce a rotating magnetic field. Field in this space is the vector addition of the fields produced by these various coils. Now most induction motors contain 3 pairs of coils, or 3 fields at 120 degrees to each other. And this is because the mains field, the mains current, is generated in 3 phases, which is just what's needed for a 3-phase motor. But you don't need 3 phases. You can make an induction motor with only 2 phases and 2 fields at right angles. So what I want to do first of all, as I showed you at the beginning of the program. Here we've got 2 coils at right angles to each other. They're both being driven by sinusoidal currents, and the result is that this little coil of copper wire, with no connections to it, placed in that field, is caused to rotate by these fields. Now the question is, how does this come about? And I want to explain this by an analogy with electric voltages applied to the plates of an oscilloscope. So let's have a look at this oscilloscope. Here we've got 2 sinusoidal waveforms. They're the same frequency, but they differ in phase by 90 degrees. Now, to simulate the behavior of the induction motor, I've got to take these 2 waveforms and apply them, one to the X plates and one to the Y plates. At the moment, they're both applied to the Y plates with a time base so that you can see that they have a phase relationship with each other. But now if I put them on the 2 pairs of plates separately, the result is the circle is being generated. If you can't see at the moment that this is a circular field, a rotating field, so if I reduce the frequency to a much lower frequency, about 1 cycle per second, you can now see that the spot on the oscilloscope screen is rotating. And what's happening is that 1 voltage is being applied to the X plates, and so moving the spot from side to side, as you can see at the moment. The other voltage is being applied to the Y plates, and it's moving it up and down. If I apply the voltage to both plates, and if they are out of phase, the result is that the spot rotates. Now let's think for a moment what this spot represents. The position of the spot relative to the 0 point is the voltage that's being applied to it. So it's being moved up and down and from side to side. But since it's moving in a circle, this means that the strength of the field is remaining the same, but the direction of the field is being rotated as a result of the difference of phase between the 2 sinusoids. And this is exactly what happens in an induction motor. We have 2 sinusoidal currents applied to the coils at right angles, X and Y plates. One is delayed with respect to the other. In this case, we have this coil, the current is delayed with respect to that one, and I know that because the coil's going that way round. It comes to this one first and then to that one. If I reverse the current in the second coil, then I'll reverse the phase of one of the sinusoids, which will mean that it's now preceding the phase of this one, which before it lagged behind. As you can see, the coil is slowing down because it's now not going with the field, it was going against it, and it speeds up in the opposite direction now with a reverse rotating field. So, you can now see that if you add these two waveforms in one central space where the coil is, you can produce a rotating magnetic field. That's the first point I wanted to make. Now, the second point relates to ping pong balls being carried along in the trough of a travelling wave. The point is this, that it's not a true analogy in that the coil in an induction motor always lags behind the wave a little bit. If it were not the case, there would be no current induced in the coil and there would be no force applied to it. You remember Faraday's law states that the EMF induced in a coil is proportional to the rate of change of field. But it's a change of field of the coil relative to the magnetic field. A change of field of the coil relative to the magnetic field. So that if the two are rotating at exactly the same rate, there will be no voltage induced in the coil, no current will flow, no magnetic force will act on it, and it won't rotate. But actually it slips behind a little bit, experiences a force, and rotates.
One way of explaining how this happens is to imagine that the flow of electricity through the coils is producing a wave-like effect, which will carry things along with it. This wave will carry a ball. It's an idea that has led to the linear motor, a device which could form the basis of a transport system in the future.
I'm going to...
This is a flat aluminium plate. Somehow, an effect produced by an electric current is causing it to float in space. We can do the same thing with this aluminium ring. We can even make the ring jump in the air. It's an effect that seems to be produced by pushing a particular kind of current through coils of wire. By arranging a number of coils in a line, we can make a piece of aluminium float and travel over them. One way of explaining how this happens is to imagine that the flow of electricity through the coils is producing a wave-like effect, which will carry things along with it.
Your help to win our success is needed. We are the tomorrow's people.
The flying saucer theme has inspired a British researcher, John Searle, who provided an alternative to our noisy and stinky means of transportation. Since 1968, he's been designing models of what he calls a levitation disc, named Starship Ezekiel, which actually flies. I've seen photographs of it, and breaks all the rules of conventional physics. It looks very much like a flying saucer. It's made of totally new materials. Motion can't be felt from its side. It makes a sharp 90-degree turn and shines strangely in the atmosphere.
Well, that's all we're willing to show you. There are many more things we would love to show you that we have been working on. A few examples are an anti-gravity technology. Yep, you walk into a room and push a button on the wall and you slowly rise to the ceiling, and then you push a button on the ceiling and you slowly lower yourself back to the floor. And you're not in a spacesuit and you're not in a vacuum, but you are indeed in anti-gravity. I've experienced that. A propulsion device. Each 7 horsepower of drive makes a G of force, which is the force it takes to levitate 1,000 pounds. Imagine putting your car in deep space using the engine that is in it and the driveway for the launching pad. That, by the way, is possible. Refrigeration with no refrigerant that can make one kitchen appliance that does every hot and cold function for your home. Washes and dries your clothes, refrigerates and cooks your food, heats and cools your home, and does literally everything. People have gotten all pushed out of shape because we say we know how to make free electricity. We actually know 8 ways to make free electricity. I will mention, plus a whole lot more that I will keep to myself. The educated idiots are talking about almost useless solar power and impractical wind power and expensive and environmentally damaging hydroelectric, and don't forget dangerous nuclear power plants. You compare. There are other ways we can make free electricity besides low temperature phase change, the Fisher hydraulic engine cycle, the permanent magnet hummingbird Sundance combination, the neutrino circuit, the momentum drive, the open-ended universal use of gravitational forces, free-flowing electrons from unique electron alignment, and non-polluting, inexpensive chemical reactions. In addition to our research, other researchers are pursuing what they call over-unity devices, but I am confident there is no such thing. Just free energy sources like what we discovered, as in the case of the scalar wave technology of Dr. Tom Bearden, who we have a lot of respect for, or Nikola Tesla's ionospheric dielectric free electricity technology that could have kept us all off Edison and J.P. Morgan's grid system in the first place. Do not get me started. Among the other things we are not showing you yet, we have been working on a technology to send any amount of live electricity any distance whatsoever with no wires and get 100% of it there. Free energy elevator lifts. Freight movement on belts that make anything pretty much weightless. Computer programs that turn a speech in English into every known language in the world automatically so that anyone can listen in their own language. We call it the Pentecost program for obvious reasons. Farm gold and other abundant precious metals in the ocean at no cost by using the nature of the ocean for energy. Turn ordinary metals into precious metals by transmutating the nucleus of atoms. By the way, the geniuses who say that is impossible could perhaps tell me how chickens do it every time they lay an egg. Separate metals by smelting them with argas. Locate and follow gold veins in mining by looking right through the ground. Remineralize the soil for farming without having to plow the field under on the 7th year. Bring an unlimited supply of fresh water anywhere in the world it is needed. Low-cost housing that lasts for thousands of years with absolutely no maintenance. Ships and submarines take their power from the water that they actually pass through. Land vehicles take their power from the air that they pass through. Jet planes, tanks, and all vehicles can run on water while oxygenating the air as they do it. Our gas can create any size vacuums to transport materials rapidly over great distances through suction tubes or gas through gas lines. Dematerialize inanimate matter and send it over wires across the country to rematerialize it when it gets there. Yes, that is indeed possible. Cell phones that use the bands of the earth to provide absolutely free wireless and untappable communications. Incredible new battery systems that don't ever wear out. Furniture and cabinets made from recycled plastic. The ability to capture asteroids, bring them back from deep space, lower them through the atmosphere slowly without burning them up, and then farm the minerals from the richest source of minerals we know of. I know that some of this sounds incredible, but look at what we have already proven. I wish I could show you or even discuss the other 80% of what has been revealed to us thus far. God only knows what else is out there that we have not yet discovered. It is difficult enough for us to learn about what God has provided, but when what we have learned is being deliberately withheld from us by those who profit the most by our existence and our free enterprise system, that should not be tolerated. There is a lot for universities in America to be ashamed of. The leaders at the top of those institutions know the truth. Their benefactors have paid a bundle to keep their students from getting full knowledge. Those who have attended those universities should be demanding their money back. Of course, they do not know what they have not been taught. A doctor at Harvard gets 1 hour of nutrition and 1,000 or more hours of pharmacology. No wonder they're all drug pushers. It's not their fault any more than the fact that electric motors are being improperly wound by trained technicians. Someone said that I am thinking there is a conspiracy, as if that were some sort of ridiculous assertion. Folks, I know there is a conspiracy, and you need to wake up and realize that this is not funny at all. It is your advancement. It's your future that is being stolen from you to help big business continue to exploit yesterday's technologies and keep you from the world God intended for you and your family to enjoy. Big business is in dire need of a good fanny kicking, and we at Better World Technologies, with your help, intend to give it to them. If after watching this video and reading the alternative book, you believe that we are con men, then you can mail these materials back to me and I will personally refund you whatever they cost you. Perhaps you've heard the phrase, people get the government they deserve. It should be obvious that we are sincere and that we are also capable. Our critics have a world order to preserve. They work hard to get you stuck on concentrating on something other than the fact that you are being lied to by those who are employed for the express purpose of perpetuating those lies. Of course, this includes public officials who are the worst liars of all. Some people are gullible enough to believe our critics when they deny their part in this conspiracy. If just about everything you are buying is fraudulent, then what more evidence of this massive lie do you need? There truly is a con going on, and you, the consumer, are the one being conned. The fact is that because we have been willing against all odds to stand up to these bullies, you do now have a chance, and you have a choice. We are your alternative. You can either support us or stay with big business and the politicians who the big business owners own, who in turn own the judges and the best media that money can buy, that is used to get those politicians elected, and that also deceive the public on behalf of their big business bosses. How could there be any doubt this is a conspiracy? How could there be any doubt we have been abused by those traitors? Why would you buy into that nonsense? We are here for you if you want us. Who else can offer you a way out of this web of deceit? We need you to overcome the system that has grown so powerful and invisible to the public. It is an entrenched conspiracy, but it does have limits. It will still change rather than be exposed. Help us change it while it is still possible to do so. This is your wake-up call. It is doubtful that anyone else will come if you let us be swallowed up. You cannot do this without us, and we cannot do it without you. A lot depends on your decision. So decide. We have already chosen to pay any price to be here for you if you want us to. The final decision, my friend, is yours.